Hello, my name's John and I'm the creator of the website caveofprogramming.com, and this is the first video in a complete course on, I hope it will be a complete course by the time I've finished it, on JavaScript and Node.js. So I started web programming, I think it was in like 1997 or something, it was a long time ago, and I couldn't have anticipated that JavaScript would end up turning into this powerful, fully fledged language that you could actually have a whole career in. Because when I started web programming, and well, for a long time afterwards, JavaScript was really a thing that you used to add a little bit of interactivity to websites. I can't even remember really when JavaScript came out, but for a long time it was a pain in the neck because it ran differently on different browsers, and it was a language that ran within a browser. It wasn't some freestanding programming language. But with Node.js, all that has changed. JavaScript has changed into a powerful, independent, fully fledged programming language in its own right. You can create websites with it, you can create web servers, you can create desktop applications. In this course, my intention is that we're going to learn the JavaScript language itself. So we're going to be doing a lot of stuff on the command line, but I want to eventually, at the end of the course, show you at least one example of how you could use JavaScript to create, let's say maybe a simple website, something like that. So my plan is actually to make this course, and then I'm going to make a course that isn't going to be free on React probably, but this is a self-contained course. In the next video, and of course, I'm hoping that you'll eventually buy my paid course. In the next video, we're going to look at what you have to install to get going with JavaScript and Node.js. Hello, this is John from caveofprogramming.com, and in this video, we're going to talk about what you need to install to get started with JavaScript and Node.js. So installation instructions are not really my thing, and they're going to vary from operating system to operating system. So my aim is here to give you enough information that you know what to install, even if you have to look up installation instructions for your particular system. So if you've already been programming for a while, this will be easy for you. If you're a complete beginner, you might have to do a bit of Googling, a bit of searching on the internet. So the first thing that we need is we need some kind of terminal where we can write commands. So if you're using Mac, by default, Mac has this program called Terminal, and you just start it up, and the language of the terminal is what we call Bash, and I can highly recommend Bash. So if you have a Mac, you can just start up a Bash terminal, it's just there already. If you're using Linux, then you probably know what you're doing with terminals anyway, and you probably also have a Bash terminal available to you. If you're using Windows, it's possible that you're more of a beginner, and then you need to look up some instructions. Now, there are two different things you could do here for Windows. One is to use the typical Windows console, but the other is you could install or enable a Bash terminal for Windows, because Bash is just so much nicer and more powerful than what's been coming with Windows over the year. In Windows 10, there is, I believe, a Bash shell, we call it a Bash shell included with it. You've simply got to enable it. So if you just search for Windows 10 Bash shell, you'll find instructions for doing that. If you're using some other versions of Windows, another possibility is there is this Git Bash. Let's Google Git Bash. Git for Windows. So you can download and install that, and that gives you, I believe, a basic Bash shell that you probably can use for this tutorial. You probably won't need that, but it's another possibility. Now, once you've decided on what terminal you're going to use, whether it's Bash or a Windows console or whatever it is, you need some software that you need to be able to run within the terminal. Specifically, we need to install Node.js. So if you search for Node.js, you can find an installation package or program for your platform pretty easily. Just download it and install it. And we need to get to the point where we can type two commands. We can type node, let's type node-v actually. We can type node-v in the terminal, and instead of saying command not found, it actually returns a version number. So the -v says return the version number. We also want a command npm -v, which should also work, should also return a version number. That's the point that you want to get to, where you can type these two commands in your terminal and they give you version numbers. So probably just installing them is generally enough. If you have any problems, don't be afraid to search for your operating system and something like install Node.js. That's what we're really talking about here, a technology called Node.js Windows. For example, you search for that, you can find detailed instructions, various pages on exactly how to install it. You could also search for things like install Node.js Windows Bash, or whatever your operating system is, or whatever terminal shell language that you intend to use. But Bash is a good choice. And again, you can find instructions. Once you've got to the point where you can open a terminal of some kind, and you can type node and npm, and it does something rather than saying command not found, then that's it, you've got it installed. Okay, so we're also going to need an editor. We need a programmer's text editor, and the one that I'm going to be using is called Visual Studio Code. Now, Visual Studio is a massive, we call it an integrated development environment for, well, it's cross-platform, but it's a massive piece of software which I used to use. I haven't used it in ages. It is good, but if you want certain features, you have to pay for them. Visual Studio Code is a completely different thing, confusingly. I don't know, maybe Microsoft wanted to just help promote Visual Studio by calling it Visual Studio Code. Visual Studio Code has nothing discernibly to do with Visual Studio. Visual Studio Code is a lightweight, partly open source programmer's text editor. I highly recommend it. I definitely recommend installing this. So again, it's cross-platform. You can use it on Windows wherever you like. So that's Visual Studio Code. And if you search for that, you'll find it. You can just download it and install it. Finally, this is completely optional. It's not central to the course at all. But you might want to install Git. If you search for Git, not GitHub, hang on, Git, and you look at that, so this is git-scm.com. You can install this Git software. Now Git there's a version of Git integrated into Visual Studio Code anyway. You can use it from there, but the ideal thing is, if you want to follow along exactly with what I'm going to do, including the Git bits, which are completely optional and nothing to do with JavaScript, then you want to get to the point where you can also type, let's try Git. Yeah, there's not an option -v, but Git, if you type that in your console, it should also do something rather than saying command not found. Just Git. It's called Git. And what that is, it's just a version control system. It enables you to store the code that you're creating and store different versions of it. And although it seems like an unnecessary extra thing, or it might seem like that if you're a complete beginner, it's so useful to be able to store your code in a way that you're not going to lose it, and store different versions of it. And so I'm going to actually create a video on next, I think, on how we're going to use Git in this course. So it's not a course on Git, but we are going to use Git. If you can't be bothered with that, really, I do recommend it, but if you really don't want to use it, it's fine. You can follow this course without using Git at all. Okay, I think that's it. So basically you need to install Node.js, you need to install Visual Studio Code, and ideally store Git as well. And you need a terminal, so you need to be able to go to a terminal, and at the very least you need to be able to type node-v, npm-v, and they need to do something. You might need to Google for instructions on how to get those working. Ideally you should get Git working there as well. And you'll have Visual Studio Code as your editor. And I think that's it. So if you can install all that lot one way or another, don't give up. If you're a complete beginner, believe me, it's not that difficult. You just need to find instructions, and ideally a bash terminal, but you can use Windows console as well. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. This is another video in my course on programming in JavaScript and Node.js. In this video, we're going to do something that's completely optional. You don't need it to follow the course, but it's a really good thing if you do it. And that is, we're going to set up a Git repository on GitHub, and that's going to be where we're going to store our code. So if you go to github.com, so GitHub is when you go to it, you're going to see something different to this. I've already created an account on there, but let's maybe see if I can just log out so I can see something more like what you'll see when you go to it. So you'll see this. Create a free account on there. Now, what is this? Well, we're going to use version control software called Git. You don't have to follow this course, but I am going to. Git stores your code somewhere. It's going to store it in what we call a remote repository. And github.com allows you to create remote repositories for free. So you can store your code and you can either make it public or keep it private completely for free, at least at the time I'm making this tutorial. So create a free account on there and sign into it. And then you're going to want to create a new repository. So your screen might look different to mine when you sign into Git, because I've been using this for quite a while, as you can see. But somewhere you'll find a button to create a new repository, and you need to click that. Okay, you need to give it a name. So I'm going to call this Node.js, I think. That will probably do the trick. Why not? Yeah. And you can type a description of it if you want. Source code for JavaScript and Node.js for beginners course. Up to you what you put. You can choose to make it public or private. If you're embarrassed about people seeing your code, you might want to make it private. I'm going to make mine public so that you can look at my source code examples here. You can add a README file if you want. That's always a good thing to do. I'm going to tick to say, yes, I want a README file in there. You can always add it later. And then there's this gitignore file. And what this is, it's a file that contains lists of files that are going to be present in the directory that you're working in, but you don't want to store them in your source code repository. And there are various standard gitignore files that we can use here. I don't know if there is one for JavaScript. Nah, I don't know. I thought there was actually. Yeah, there's one for Node, look. So if you search for Node and select that, that's a good one. License, you can change that as well. I'll use the MIT license, which as far as I understand means anyone can use my source code for anything. I'm not sure if they even have to attribute me, but I don't care here. You can use my source code for this course as you see fit. And then when you've done all that and decided on all that, just click Create Repository. And this doesn't usually take long. Here we go. So this is a source code repository which we're going to check code into as we go along. Now I'm going to click this clone or download button, and I'm going to just copy this this URL here, and I'm going to go to my terminal. Now we can actually do this, I believe, from within Visual Studio Code. I haven't looked up how to do that, but to do what I'm about to do, you don't have to use the command line. You can use a variety of tools that, you know, Git user interfaces, but I'm just going to do it on the command line. Here I'm using a bash terminal. So if you're using a Windows console instead, you want to probably spend just a little bit of time just checking how to use that sort of basic usage of it. The Windows console by default will tell you where you are. It says like C:/ whatever. It tells you where you are in the directory structure, and you're going to need to just understand the directory structure thing to follow this course, you know, but that's just basic sort of computing. If you've played with a computer for a while, you'll know what a directory is and so on. Okay, so in Bash though, it may or may not show you where you are by default. You can find out by doing pwd. So if you are using Bash, you can type pwd and it'll tell you where you're located in the directory structure. To change directories in Bash, I think it's the same in Windows. You just do cd space and the directory that you want to change into, You always need that space in bash though. I think Windows lets you do cd ... to go to the directory above, but that doesn't work in bash. You need cd space ... Pretty similar, really. That's change directory. So if you play with that for a bit, you'll get used to it. So I can go to the directory above. In Windows, I do dir, if I remember rightly, to see what's in here. In a bash terminal, I can do, whether it's on Windows or not, I can do ls, shows me where I am, and I'm just going to change into this directory here. On bash, usually you can use tab as well to autocomplete directory or file names. All right. So anyway, I'm in a directory where I want to put my work, and I've got Git working in here, so I can use Git. If I type Git, it actually does something, and I want to do Git clone, and then paste in that URL, hit return, and this is going to take my remote repository and basically create a local version of it. So if I do ls now, or dir, I suppose it will be in Windows console. Now I can see that it's created this Node.js directory. It's called Node.js because that's what I just called it on github.com when I created that repository. I can cd into this, change directory, and do ls or dir or whatever. And you can see what files are in it at the moment. This is where I'm going to be creating my source code. So we'll create source code in the next video, I think, and we'll also look at how to check it into Git. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this video we're going to create a Hello World JavaScript program. So we haven't really quite finished installing things here, so I'm going to assume that by now you have got some terminal installed that you're happy with using. I'm going to assume you're using bash, but if you can use Windows terminal or whatever, you just need to make sure you're okay with using it and you understand it. And you should have got Git installed ideally, and you should have you'll definitely need Node and npm. You'll need all that. And you'll need a programmer's text editor, and I will assume that you've got Visual Studio Code installed by now, or else another text editor that you're familiar with and you know how to use. Okay, so one thing is, Visual Studio Code out of the box doesn't necessarily support JavaScript programming well. What we need is two things. We need a syntax highlighter, which will color different parts of the code that we're going to write in meaningful ways to help us understand it. And we need a kind of a prettifier or formatter that will automatically format or arrange the code in a way that makes sense. So what I'd recommend is when you start Visual Studio Code for the first time, usually you'll get this welcome screen, and it says customize here, install support for JavaScript. You probably want to click that and just do it. If you don't see that in Visual Studio Code, you can also just search on the internet for something like Visual Studio Code JavaScript plugins, something like that. Because you need to install plugins that will enable you to work well with JavaScript. Go to maybe this page at code.visualstudio.com, install whichever of these seem like they might be useful, like Prettier. I think will be definitely a good one to install. You'll figure out pretty quickly if you've got the right support that you need in Visual Studio Code or not. And you can also, if you look at Visual Studio Code, at the moment on the left, at least in this version I'm using in 2020, there's like this icon. It looks like a sort of some building bricks, and if you click that, it opens an extensions panel. Where if you've got an internet connection, which you have because you're watching this video, unless you've downloaded it and you're watching it later, then you can search for extensions here. Like you could search for JavaScript and install them here. So I've installed some extensions basically, but the bottom line is you've got to have a formatter and a syntax highlighter. Let's take a look. All right, so I'm going to get rid of this now. and I'm going to open the Explorer, File Explorer, with this thing here in the top left, this icon. And if I click that, I can open a folder. So I'm going to open that folder we created in the last video. You can either just create that manually, or even better, create it by cloning your remote Git repository like I did in the last video. So I'm going to click Open Folder, navigate to that video and just select it, click Open. And then it shows me what's in that video. Actually, I've opened the wrong one here. I don't think I wanted to open that. Let's go to File and Close Folder. And then I'm going to make sure I open the right one. Click Open Folder, and what I want is this folder that I just created in the last video using Git clone. So I click Open, and there we go. This is the folder. So it's got a .gitignore in it, and a license file, and a readme.md, which is just a text file. Now I'm going to create a new file in there. You can either do that by going to File, New File, like any reasonable text editor. Well, that's a bit of an exaggeration, because Vim, for example, is a reasonable text editor, but doesn't work like this. But anyway, like most text editors that have a GUI, graphical user interface, you can go to File, New File. Or if you look in this File Explorer, above the if you hover over the folder name, there's a new file icon. There's also a new folder icon. Let's click the new file icon and give it a name. And I'm going to create a file called helloworld.js. You can call it what you want, but I would recommend giving it a JS extension. And because I've installed various plugins, the fact that I give it a .js extension means Visual Studio Code will recognize that this is supposed to be a JavaScript file, and that's why it suddenly popped up that yellow JS there. It may or may not do that on yours. Depends what extensions you've installed. Okay, now let's type a program. So I'm going to type So I'm going to show you what to type here. I'm not going to explain it that much. You're going to come to it to understand it more as you go through the course. If you've already got programming experience, this won't be a mystery to you. If you're a complete beginner, it will be more of a mystery, but that's all right. The important thing at the moment is to actually type this yourself. So you can't learn programming just by watching videos. That's like trying to learn to play the piano by watching videos about people playing the piano. You have to actually watch the video and try the thing yourself, whether you try it now or afterwards. You've got to do it yourself if you really want to learn this. I don't know whether I'm going to give you suggestions for exercises. I probably will as we go along, but the really important thing is you try out what you see me doing and also experiment with it a little bit yourself. So I'm going to type here console.log and then 2 round brackets and then a semicolon, like that. You've got to get it exactly correct. It will actually work without the semicolon in JavaScript, but I usually try to put it in. I feel it's good practice. And then I'm going to put the cursor inside these 2 round brackets and type a quote like this, a quote mark. And because I've got various plugins installed, Visual Studio Code put the closing quote in for me. So I've got a pair of single quotes there. It's not a speech mark, it's 2 single quotes. Notice also that console is a different color to log, if you can see that. I've got syntax highlighting going on here. Again, that's because I installed syntax highlighting extensions like Prettier, for example. You want that working, ideally. It makes programming much easier. So I'm going to click between these 2 single quotes and type hello space world exclamation mark and save that file. All right, so this is a really simple, basic JavaScript standalone program. And now I'm going to run that. And to do that, you probably can run it from within Visual Studio Code. There's also, by the way, you can also open a terminal within Visual Studio Code. But I'm just going to run it from my freestanding terminal program. So I'm going to assume that you have a terminal that you're happy with and you know how to use, or else you're using Bash, and you can just follow along with me here. Let's go to the terminal. So I'm going to type pwd in Bash to see where I am, and I'm not in the right place here. So I'm going to do cd space dot dot to go up a level, cd space dot 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 to go up another level, and I'm going to do pwd, and then let's do ls to see what's in here. Okay, I'm going to cd space into my Node.js folder. This is going to be different for you. You know, it just depends what folders you've got. I just wanted to show you a bit of how you navigate in Bash. I'll use the tab key to autocomplete, which will probably work for you as well. Depends what operating system you're using, maybe, I'm not sure. And then hit return, ls, and I'm going to do cd space. Basically, I'm going to change into that directory that we created in the last video. I hit return and ls to see what's in it. And okay, there's my hello world.js. ls is short for list, by the way. cd is short for change directory. pwd, I can't remember what that's short for, but it shows you where you are if you're using a Bash terminal. Now to run this, I just type node space hello world.js and hit return. Again, I was using the tab key to autocomplete the file name there. Hit return and it says hello world. Okay, so what have we done here? Well, Node is an interpreter. That is, it can take a file containing instructions in the JavaScript language and it can carry out those instructions. And the instructions that I wrote here basically say, we call it printing. So print the text hello world. In other words, display that on the console. And that's the result. So my Node program has run the instructions in my hello world.js file written in the JavaScript language, and it's done what I told it to do. It's printed hello world. Printing here has nothing to do with printers. It's programming lingo for display on the console. So if you've got some programming experience, you may be underwhelmed by this. You know, it's the first step. It's great. You have to do it. You may be surprised that you can do this with JavaScript. I certainly was, to find that you can run JavaScript as a freestanding program these days using Node. This was a surprise to me when I first did this. If you're a complete beginner, this may feel all very confusing, and you won't know, why console, why log, why any of this. That's okay. Your confusion will go away as you carry on going through the course. The important thing is to follow along with what I'm doing, either after the video or during it. Type out this stuff, get it working yourself. That's absolutely vital. And also experiment with it a bit. So in this case, you could probably guess that you can change the text hello world inside these single quotes to something else, and it should still work generally. So try that out for yourself. And I'm going to assume that you are typing this stuff for yourself and experimenting with it a little bit. Otherwise, you just won't learn what's in this course unless you're an experienced programmer, maybe. And then you could probably just watch the videos and apply them just from memory. I don't know, maybe. But anyway, okay, so we'll leave it there for this. No, we won't. I've got another thing to do. Before we leave this video, let's check our code into Git. So in the last video, I created a GitHub repository, and this directory that we're in is a local version of that. So now if I type git status, hang on, let's just do clear first. So I just type clear to clear the console, git space status. If you've got Git installed, you'll see a message like this. So this is actually showing in red. It may or may not do for you, but it will probably say untracked files, hello world. So what I want to do is I want to, we say stage the changes for commit. It's Git lingo. This isn't really a tutorial on Git, but I need to tell Git about this file. I need to tell it, look, store this file. So I'm going to say git add, and I'll just use git add star to say, look, add everything to the Git repository here. And after that, or I could just do git add hello world.js. It doesn't matter which one really. If I then do git status, now it says changes to be committed, and it tells me what command I would use if I wanted to undo what I just did. And it says new file hello world.js. Now I can write git commit and then -m to add a message, and so I'm committing to Git, meaning now I'm actually saving my changes in my local Git repository. So git add says, look, take notice of these files. They're important, basically. We say that we're staging changes for commit. Commit actually saves those changes in effect, the changes that we made to this file. We created it and added text to it. We want to save all that. And it's the commit that's actually saving it, basically. So I'll do git commit -m, and then I'll just put a message created in double quotes and hit return. Okay, and now if I do git status, it says, let's just do clear and git space status. It says on branch master, your branch is ahead of origin master by 1 commit. Use git push to publish your local commits. So I've committed to my local Git repository. I've saved the changes that I've just done, but I want to send them to the remote repository on github.com because, you know, if my computer gets messed up, I don't want to lose my changes. So I'm going to save the local changes in the remote repository. To do that, I write git push origin master. So 4 different words there. So I'm using git, I'm doing a push command. I'm pushing to the origin, in other words, to the remote repository. And this is what we call a branch name. It's a particular version of this code, basically. We won't dwell on that too much, but I'm going to hit return. You might need to add a username and password at this point. It's not asking me to do that because I've already run Git, but it will probably ask you to add your GitHub username, which is probably an email address, and your github.com password as well. And it may also ask you to configure your email address, and it will tell you how to do that, probably, if it asks you to do that. So you probably won't have too much trouble with this. It's not too confusing. So there's 3 commands that we did there. Let's do let's do history grep git. You don't have to do this, but I want to look at the history of things that I've done and filter that. So grep filters it. So I want to run this through grep and just see the ones that contain the word git. And we can see that what I did was basically I did git add star, git commit -m with a message, and git push origin master. Those are the 3 commands that I used to save what I've done. Git status was just used to see what's going on, basically. And you might need to do other stuff. Like just add your password the first time you do this. Okay. When you've done that, you should be able to go to github.com, and well, if you log in, you should be able to see your repository there, and you find that your source code has been added to it. And there it is for me. So you may or may not decide to use GitHub. It's not an essential part of this course, but whether you do or not, if you want to see my source code, the stuff that I'm creating, you can go to github.com/caveofprogramming. And then you want to go to my Node.js repository. So either just go to /Node.js directly, or click on my repositories tab and go to Node.js. So basically go to the URL github.com/caveofprogramming, all one word, /Node.js. And then you can see my source code in there, and here's hello world.js. So after this tutorial, I'll probably start giving these kind of numbers so you can basically, kind of keep track of them a bit better. All right. So that's it for this video. Hopefully you ran your first Hello World program. If you're a complete beginner with programming and you managed to run this, that's an incredible achievement. Believe me, be proud of it. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at variables in JavaScript. So I'm going to start by creating another file here. Let's go to the File menu and New File, or I can just use this icon here in the Explorer in Visual Studio Code. So either way is good. Let's take a look. So I create a new file. I'm going to start giving my files names that have section numbers and file numbers in, just to help me organize this course and so that you can find my code more easily on GitHub. But you don't need to do that, of course. So you could call this variables.js, but I'm going to give it a number and call it 01050 space variables.js. All right. Now let's write out. Let's basically recreate the hello world program that we had last time. So I'm going to write console.log and single quotes and hello world. And at the end, we should really put a semicolon. It will work without that, but a semicolon is kind of used to define the end of a statement, a complete sort of little bit of code in JavaScript. And I think it's good practice to put it in generally. Okay, so now we can go to the terminal, zoom out a bit here, and if I do ls in this directory, I can see my new file, and I can run it with node and the file name. So I've used a tab key to autocomplete the file name here, and because I've got a space in mine, in order to stop the bash shell interpreting this as two file names, one called 01050 and the other variables.js, the bash autocomplete helpfully put a backslash in front of the space that stops it being treated as a separator character. If you just called your file variables.js and it's not got spaces in the file name, though, you won't have to worry about any of that. All right, so let's run it and check that it works. It says hello world. Okay, now we could use what we call a variable to refer to this hello world message. And you'll see as we go along through the course that variables are a key part of computer programming. They're absolutely a fundamental building block that we use here. So let's write this. I'm going to make up a name. I'm going to create a variable called message, all lowercase, and I'm going to set that equal to, in single quotes, hello world, and I'll put a semicolon at the end. And then we're going to output this variable, or the value of this variable, in console.log. I'm going to write console.log, and in the round brackets I'm going to put message. So what have we actually done here? Well, first of all, let's just see it running. If I run it, it doesn't seem to do anything different to before. It just says hello world. So this is what we call a string in computer programming, this bit of text. And message, it's like a label that I've devised. So if you think about it, okay, this text here, when the program runs, it must be somewhere in the computer's memory. And it's as if we put a label on that bit of memory called message, so that we can use the label message to refer to this piece of text later on. And then we say console.log message. We can also do this with numbers. Let's go down and create another variable. Let's call this, I don't know, let's call it days and set it equal to 7. So it's like the number of days in a week. So days equals 7, semicolon. And then if I write console.log days like this, and then let's go back and to the terminal and run this. So some people get confused because at this point it looks as though we're saying days equals 7, and what does that even mean? That's not really what we're doing. This equals here is what we call the assignment operator. So these are variables, message and days are variables, and we're using equals to assign a value to them. You can think of it as though we're storing a value in them, although I think in JavaScript, arguably it's more accurate really to say that these variables are like labels that we use to refer to these values, these literal values we call them. But basically we say here that we are assigning values to variables. So I've assigned the value hello world to the variable message, and I've assigned the value 7 to the variable days, and then we can output those. Try those for yourself, and we'll discuss this more and look at some refinements to this in the next video. Hello, this is John from caveofprogramming.com, and this is another video in the JavaScript and Node.js for Complete Beginners course. So in this video we're going to look at declaring variables. In the last video we saw how you could create variables. So what we're doing here is here I've got a variable called message, and we say that I'm assigning it the value hello world. Notice that text is in quotes because it's what we call a string. And then later on, after outputting that on the console, after printing hello world, I create another variable and assign it the value 7. Notice the 7 is not in quotes, and that's because it's a number. We don't put numbers in quotes when we want to use them actually as a number. So if I want to add and subtract things or whatever with this days value, then we don't put it in quotes. So again, we're assigning the value 7 to a variable called days, and we're outputting it. Now we're going to be looking at this, and if you're a complete beginner, you'll probably, this is totally new to you. It might seem confusing, probably it will, but you develop fluency with it just by using these ideas, and it will become clearer later on. What I want to show you here is we want to start off using best practice, and there's a problem with what we did in the last video. So supposing I wrote message equals hello, we can use double quotes or single quotes, it doesn't matter, it's just whichever you prefer. There's no difference between them in JavaScript. Hello world, let's write that, and console.log message, put in double quotes either. That's a mistake beginners sometimes make. Only text values get put in quotes here. All right. So later on in my program, I might write message with only one S as a mistake, and I might say equals I don't know, how are you? And then write console.log message. Let's run this program. I'll maybe clear my console to make this less confusing. All right, so this kind of does what you expect, really. This second variable with the misspelling is a completely different variable to this one. Now, if you've got a big program, and it can be very easy to misspell a variable name. So it might have been my intention here to change the value of this variable, which you can do. You can give it a different value later on. But what I've done instead is I've basically created a completely new variable with a different name just because I misspelt it. So perhaps it was my intention to do this, just to change the value of this variable, which you can do. But because I misspelt it, I created an entirely new variable. Now the upshot of this is that it's not good practice to simply create variables by directly assigning a value to them like this. There are two things that we should do. So we're going to do this in every JavaScript program that we create. Firstly, at the top, we're going to write this in double or single quotes. We're going to write use space strict and then a semicolon at the end of it. Now, if we write message equals, let's say hello, and then try to output message, console.log message. Let's try this. We get an error, and that's actually a good thing. What useStrict forces us to do is it forces us to use a keyword to declare our variables, and the keyword that we usually use is let. So I say let message equal hello, and then I output message. And if we run this program, now it says hello, it actually works. Okay, so if you've been using JavaScript for a while and you're not a beginner, then you will have also seen the keyword var. So we could also use var like this. Var message equals hello. Var, you might guess, is short for variable, and this also works. What's the difference between them? Well, let is kind of a later introduction to JavaScript. We're going to be using let for various reasons that I'll go into later on. But for now, you just have to know that when we create a variable, we should write let. So let message equals hello. And you can change it later if you want to. Let's take a look. So I can say message equals how are you, question mark. And now let's output it again to see how it's changed. Console.log message. And we'll run it. And it says, how are you? So if we look at this, what we've done here, when we say let message, we call this declaring a variable. Now, you can put comments in your JavaScript. If you want a single line comment, if you write 2 forward slashes like this, everything that you write after that will be a comment. So let's write here, declare the variable message and assign the value hello to it. All right, and then what we're doing here is we're print the variable. Let's just write print message. And here, what we're doing, notice there's no let keyword here. We've declared the variable, and we only have to declare the variable once in our program. Here, what we're doing is just assigning a new value to an existing variable. So here we're saying assign a new value to the variable message. So we declare a variable, we assign a value to it with the assignment operator equals, we display it or print it on the console. Later on, we assign a different value to it, to the same variable, how are you, and we print that again on the console. And if we run this program, it does this. So don't worry about this too much. Again, if you are a complete beginner, this will be confusing. I've seen people try to learn programming by writing loads and loads of notes, and that's the wrong way to learn it in my view. The right way is just to practice it. So the thing to do now is type this program out for yourself, if you're a beginner especially, and get it working and run it, and don't sweat too much over what it's doing. But look at it and think, is there any way you could change this that wouldn't break it? And if you can think of any way, then try that out. I'm sure you can think of some changes at least that you can make to this program that wouldn't break it. Have a go. See if you can change this without breaking it once you've got it working. But get this working first. So type it out, get it working, and then try to experiment with it and see how you get on. And you'll find that as you keep typing stuff and experimenting with it, gradually your confusion will go away and your fluency will build up and it will all begin to make sense. But really, learning programming, I always say it's kind of in the fingers. You've got to type stuff and experiment with it. It's useless, in my view, to make loads of notes and to really stare at something and agonize over it and try to understand what it means. A lot of the time that's useless. It's much better to actually type it out and practice it and play around with it. Okay, so we'll leave it there for this video. Until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this video we're going to take a look at command line arguments in Node.js. So we've seen that you can write use strict like this at the top of your files. I'm in just an empty file here which I've called commandline.js, and you can declare variables like this. Let's write let greeting equals hello, and you can output stuff. You can print it on the console like this, console.log greeting. So I've declared a variable called greeting, I've assigned a value to it, hello, and I've printed the value in that variable, and I can run this from the command line by writing node and the name of the script, and it says hello. Now you can actually output multiple variables or values with console.log. So let's supposing I want to output a name or some text here. I can write comma and in single or double quotes a name. So I'm going to say hello to myself here, hello John. If I run this, let's try it, it says hello John. Notice there's a space between them, although there's no space here that you can see. Well, there is a space there, but the thing is JavaScript doesn't take notice of spaces in your code. It would take notice of a space in your string. Let's maybe change this to single quotes for consistency. It doesn't matter which you use though. Output multiple variables or values like this. It will helpfully variables or values like this. It will helpfully separate them by spaces so that they're easier to read. Now, do try this out for yourself. And what I want to show you here is that there's a special kind of, well, it's actually what we call an array, argv, that contains various useful values. So let's try outputting stuff with argv here. So I'm going to write console.log and process. Don't worry about what process and console and stuff like this are just at the moment. Process.argv, and then we have two square brackets like this, an opening and a closing square bracket, and in there I'm going to write 0. Right, so we've got two console.logs. Let's run this program and see what it does. So we've got the hello John, that's still there, but what this console.log process.argv0 did was it output actually the location of node, the node program that we're using. You'll probably get something different. It just depends where you installed it and how you installed it, you know, but you'll get the location of node, hopefully. If we change this 0 to 1, there's something else in there that is sometimes potentially helpful. It's the location of the program that I'm running. Location of the program that I'm running, commandline.js. That's the file that I'm actually running. And there's another possibility, process.argv2. Now if I run this, it's just going to say undefined, but here's what it actually does. Let's just clear this. I'll say node commandline.js, and I'm going to type something like giraffe, and it outputs giraffe. So you can see that this text here is actually outputting what I've typed on the command line here, which in this case was giraffe. Now, if you've done some programming before, you'll recognize argv as a array, and if you haven't done any programming before, this will be like completely cryptic. as far as you're concerned, but that's all right. That's all right for the moment. You'll come to understand this in time as we go through the course. Notice there are two places where I've written something dot something. There's console.log and there's process.argv. Those are what we call objects in JavaScript. And if we search on the internet for Node.js global objects, there are a bunch of these things. Let's go to this link here at nodejs.org. And you can see in here there's console, there's process. There are a bunch of these global objects that we can access. Never mind about what they are. Just know that there are several different ones. And in fact, log here is what we call a method. It's essentially a subroutine. It's some code that we can run, some lines of code basically. And argv is what we call an array. And we're going to be going through all this in great detail. But for the moment, let's just make use of this. So this process argv, let's get the value of it in a variable. Let's say let name equal process.argv. So whatever the user enters after the program, we will take that and we will put it in the variable name. And then when I do console.log, I'll write console.log greeting and then name. Okay, so again, if you've done programming before in some language, this will probably be very straightforward to you. But in case you haven't, it'll look a bit mystifying. Do type it out for yourself. Essentially, we've got two variables here. One I'm setting directly with what we call a string literal, an actual hard-coded value, a value I've written directly into my program. So greeting is assigned this value. We've got a variable called name, which is assigned a value from this thing here, and that thing there contains whatever you type after the name of your program when you run it. And then we're outputting both of these variables one after the other. Let's try this. And so I'm going to write node command line and some name like Joe or whatever. You can write your name there. Hello, Joe. Notice if I write two things, let's write a surname. It only picks up the first one. That's because it's considering this to be another what we call command line argument. So this is the first command line argument, and that's another command line argument. We could access that using the number 3, but we won't worry about that here. All I want to do is get some minimal stuff off the command line, and I'm happy just with one bit of text. Okay, try all that out for yourself. If you are a beginner, this stuff is confusing, and there is this just initial feeling of confusion that's always associated with learning programming at the beginning. And also, if you have programming experience and you switch from one language or framework to another, it doesn't persist as long, but often you sort of recreate that feeling of confusion slightly, and you just have to persist through it, because the important thing at the moment is that you type stuff and you just see what it does, and ideally experiment with it a bit yourself as well. And gradually this will become second nature to you. And as we go through this course, I'll be able to explain to you all of the stuff that's going on here. So eventually it will lose its mystery. But I can't just explain it all now, because the explanation would involve just too many different concepts and you would get lost. So you need to just practice this stuff that I'm showing you, kind of just practice typing it and getting it working, and you'll gradually get used to it. One thing that I should do here is, since I'm using Git in this course, I should check this into Git, but I can't. I'll do that after I've paused the video. Okay, so until next time, happy coding. Hello, in this video we're going to take a look at arithmetic in JavaScript and Node.js. If you've done some programming before, there are probably no surprises here, except that Java, C, C++ and some others have this concept of integer division, whereby dividing an integer by an integer always produces an integer or whole number. And there isn't such a thing in JavaScript, so division works as you might expect if you've never heard of that. But anyway, putting that aside, so addition works like you'd expect in JavaScript. Let's do console.log 5 plus 4. Just zoom in a bit, maybe. Well, let's run this. So node arithmetic. Oh yeah, I called this 01080. Let's run this. 9, is that right? Yeah. Subtraction is it's exactly like you'd expect as well. Five. We've got multiplication. So let's say 3 times 4. So we use the asterisk symbol in JavaScript for multiplication, as we do in many other languages. And there's also division. Let's do maybe 7 divide by 2. So this is all pretty much the same as other programming languages. Let's just run it. 7 divided by 2 is 3.5. 3 times 4 is 12. We've got the mod operator as well. So the mod operator basically gives you the remainder from a division. So if I change this to mod, it's a % sign. Let's just make a comment, mod operator. So 7 mod 2, well, if you divide 7 by 2, but then work out the remainder, so that's obviously 1. Let's run it. 1. And the mod operator actually in JavaScript will also work with, at least with Node.js, it will also work with values that aren't integers, that aren't whole numbers. So if I write like, I don't know, 12.3 divided by 3, let's say divided by 5, that gives us 2.3. So sometimes it can be a bit confusing because like numbers that are like floating point numbers can't be stored in a completely exact way, not only due to the nature of computing, but due to the nature of reality. If you've got like a number with an infinite number of decimal values after the decimal point, an infinite number of significant digits, you can't store it exactly. And so sometimes, like if you're expecting 2.3, you might get 2.299999 and so on, and you might wonder what's happened, but it's just kind of just the problem of being able to represent floating point numbers exactly. It just can't be done. But here you can see that if you divide 12.3 by 5, you can fit 2 5s into that, and you've got 2.3 left over, which is what the mod operator is giving us here. Usually you use the mod operator with integers in programming, and it can occasionally be very useful. There's also, it's probably worth mentioning, there's also a couple of what we call unary operators that apply to variables here. They're intended for use with integer variables or whole numbers. Well, that is variables that refer to a whole number value. So plus all of these, plus, minus, times, divide and mod, we call them binary operators. They operate on something. They operate on 2 numbers. Binary operator meaning like 2. It's an operator that operates on 2 things. So each of these basically takes in 2 values and then returns a third value, if you think about it. You know, like so we take, for example, 5 plus 4. We've got 2 values there, 5 and 4, and that produces, we can say, or returns a third value, which is 9. So we call these binary operators because they're operating on 2 things. There are also unary operators that operate on a single value. So let's say we've got a number like let value equal 2. If we do value plus plus in JavaScript. Let's do console.log value. That just increases the value of this variable by 1. And if you're new to programming, hopefully you're beginning to get the idea of what variables do. I'll give you some practice with them later on, but you can use variables essentially instead of the values that they contain. They're kind of like a label for values in a way. So what this does is, so initially we declare the variable called value and set it equal to 2, and then we increment it. We increase the value of it by 1 using this plus plus operator, and then I'm going to output it, so we're going to see 3. So if I just run this, we get 3 there. There's another version of that looks like this. So hang on, let's maybe put that there, and then there's plus plus value as well. That does nearly the same thing. There is we call the postfix version, and this the postfix version, and this the prefix version of it. There is a difference between them, which we'll doubtless see later on, but it doesn't really matter here for the moment. So you can see we've increased it again to 4, and we've got the same thing for like a minus minus version of it. So let's take a look at that. So we've got minus minus value, or there's the postfix version as well, like this. Looks like this. So that's that decreases the value of a variable that refers to a number by 1. So we've gone from 4 to 3 to 2. Okay, I think that's it for this video. What I'm going to show you next is we're going to implement a little program to convert temperatures between Fahrenheit and Celsius. So you can have a go at that if you want, if you can think you might be able to figure out how to do it. If you've done programming before, it should be easy for you. And if you haven't, then it might be difficult, but see if you can do it. I need to check stuff into Git here. Usually I do it on the command line, but let's just see if I can actually do it using Visual Studio Code. So I don't usually do this, but we've got, if I go to this, there's this view here that shows us kind of the source control view. It's like this icon in the top, so near the top left here, sort of sharing type icon. And if I hover over it, it says source control. Several files I've got here have a U by the side of them to show that they're untracked. I haven't done a git add and the name of the file or a git add star. So I can add them to version control. I think with this plus value, if I hover over that, it says stage changes. Let's do that. And then the U goes away. Well, that actually seems fine. And so now I should be able to do a commit. If I hover over this changes, that gives me a stage or changes. Oh yeah, I see it. I couldn't quite remember how to do this, but once I've staged things for commit, I can then do a commit, and I can add a message here. Let's just put created in here, and then there's a tick at the top here to actually do the commit. Let's try that. I think that worked. Looks like it worked. I could verify on the command line here. If I do git status, yeah, the only thing I've got to do is a push to my remote repository. I'm not actually sure how to do that. Yeah, let's try clicking these dots and going to push. Does that work? Because I can see progress bar. Would you like code to periodically run git fetch? No, because no one's going to change this repository apart from me. Well, it did something. Let's have a look now. Git status. Yeah, looks like it worked. Okay, so we can do all our Git stuff from within Visual Studio Code clearly, but I do in general prefer the command line. It gives me more of a feeling that I know what's actually going on. Okay, we'll leave it there for this video. See if you can write a program that converts like Celsius to Fahrenheit or Fahrenheit to Celsius if you like, and we'll come back to this in the next video. Hello, in this video I'm going to write a little program in JavaScript to convert temperatures in Celsius to temperatures in Fahrenheit. So if I go to Google and I write convert Celsius to Fahrenheit, and it will give me a formula. So I take the value in Celsius, I multiply by 9 divided by 5, and I add 32. Right, so let's try that. So when I grew up, I was familiar with Fahrenheit and probably Celsius as well, because the UK was kind of switching over from one to the other. But now I'm much more familiar with Celsius, and in the USA, I believe Fahrenheit is much more common. So these are both commonly used. At least Fahrenheit is used in the US and probably some other places. All right, so let's create a new file here. So I go to the File Explorer and create a new file. Let's call it convert temp, or yeah, that'll do, convert temp.js. Maybe I'll put an underscore in there. All right. So let's start off with use strict, because this ensures that I have to declare variables before using them, and that's a good thing to have. It reduces errors. And we need to get the value in Celsius. I'll get it from the command line. So I'll assume that the user has typed node convert temp.js and then a temperature in Celsius that they want to convert. At the moment, with the syntax we've seen, which is very limited, we have no way of checking if they've correctly typed something. We can't even tell them what to type yet. We can't output a message before the script runs. It's not possible. But we're going to improve on this a lot later on. So we'll just do what we can for the moment with the syntax we've got. So we've seen that we can get, let's write let Celsius. We can get arguments from the command line via process.argv2. So remember, the first, if we write process.argv1, that would give us the name and location of the Node.js program, the program called Node. Process.argv1 is the name and location of our script. Process.argv2 is the first thing the user types, if anything, after the name of the program, and process.argv3 will be the next thing they type after that, and so on the command line when they run the program. So let's assume we can get Celsius like this, and we can just output it with console.log just to check. So if I do just if I clear this and write node convert temps.js, if I don't type anything afterwards, that's going to come out as a value called undefined. But if I type something like 21, which I would consider room temperature, then it's echoing back the value that I typed. Well, I just did something here. Okay, there we go. So that seems to be working. Convert it to Fahrenheit. So let's say let Fahrenheit equal. We need to take the value in Celsius, multiply it by 5 divided by 9, and we need to add 32. So we should be able to do it like this. Let's try. Let's write console.log, and let's write out the value in Celsius, comma, in Celsius is, comma, Fahrenheit. So if you can see what this is doing, I'm trying to write something like, for example, 21 in Celsius is whatever it is, 65 in Fahrenheit. I'm trying to make my output look like this. And remember, we can output multiple values using console.log. Doesn't matter if they're variables or they're literal strings like this, bits of text, which we call strings, that I've literally written exactly there. We can output them with console.log, and we can output multiple values by separating them here by commas. Let's try this and see what that looks like. So I'll just clear my console and use the up arrow here to bring back this. And if I run it, 21 in Celsius is 43 in Fahrenheit. I made a mistake here. I should have 9 divided by 5 instead of 5 divided by 9. Let's try it. There we go, 69.8 Fahrenheit. That looks right to me. We could check on Google, of course. Let's say 21 Celsius to Fahrenheit, 69.8. So that seems to be correct. Let's just correct this. It's about 70 Fahrenheit, basically. Okay, now this expression here, okay, it worked, but it looks a bit ambiguous. There's this thing called operator precedence that determines which operators run first. For example, there's a question here, do we do Celsius times 9 divided by 5 and then add 32, or do we do Celsius times 9 divided by 5 add 32, or do we even do Celsius times 9 and then divide by 5 plus 32? You know, it could be seen as ambiguous. In fact, in this case, operator precedence just takes care of this, and it works as you might expect. But in general, with expressions like this, if you have any fear that operators might run in a way that you don't want, you can use round brackets to make it clearer what's going on. So in this case, I would consider putting round brackets here around this bit, just to make it a bit clearer. Then it makes it clearer that we're doing Celsius times 9 divided by 5. It doesn't matter whether we do Celsius times 9, then divide by 5, or we do Celsius times 9 divided by 5. It's the same anyway. And then add 32 after all that. Let's check that it still works. There we go. Yeah. So you can put round brackets in to make this clearer. If you are new to programming, then you need to practice this stuff a lot. You know, practice it quite a bit, I would say. So one good thing to do is just, you know, try to convert one thing to another. You know, try to convert, for example, measurements in feet and inches to measurements in meters, whatever you like. Or another good one is, you know, working with dates. Like you can do stuff like try to convert a certain number of days to a period specified in like months and years or something like that. There's lots of things like that you can do. Use your imagination, but you want to practice using variables, using arithmetic, and outputting stuff with console.log. Practice all this stuff thoroughly. Spend some time on it if you're new to programming. If you've done programming before, this is old stuff to you. You probably just are watching this to know where JavaScript is different. So I'm going to try to go not too slowly. I'm not going to dwell on every operator here because I'm aware that many people will have some prior programming experience, but I want to keep it simple enough that you can follow this course with no programming experience at all. But if you haven't got no programming experience at this point, you want to play with these ideas a bit. Try to write different little programs that convert one thing to another. If you don't always succeed, that's okay. But the important thing is to try, because you just need to become more familiar with using variables to see what you can do and what you can't do. And we're going to be looking at obviously more examples as we go through the course. Okay, so until next time, happy coding. Hello, in this video we're going to look at comparing numbers in JavaScript. If you've done programming before in some other language, you can skip this video because there are no surprises in this particular one. This is stuff that is the same in many different programming languages. So let's start off with use strict here because I want to force myself to declare variables. Now we can write console.log and we could compare, for example, 7 with 7. Supposing we want to know if 7 is equal to 7, which it clearly is, we can write 7 equals 7. Now this equals here is the equality test operator. It's unlike the single equals sign, which is used to assign values to variables. The double equals sign is the equality test operator. It's used to check if two values are equal or not, and it returns either true or false. I say returns, meaning this whole expression here will evaluate as a whole to either true or false. Let's run this. So what did I call that? I called it comparing numbers. So if I run node comparing numbers.js, it says true. Now this is a bit useless because we know that 7 is equal to 7, but I could have one of these values stored in a variable. Like let's write let's call it days in week equals 7. And notice the way I write this variable here is called camel casing. So I've written the first letter lowercase, and then each subsequent word that it's made up of, I write with an uppercase first letter for readability. This is called camel casing, and it's a very common convention in JavaScript, so it's what I'm going to be using here. It's important to stick to consistent coding conventions. Now, so I can compare days in week here with 7. Is it equal to 7? And that's going to be, of course, true. True. Whereas if I asked, is it equal to 6 or something, then it's going to be false. And this might not seem like much, but this is sort of a key part of programming, really, comparing values like this. This might be something you've got from user input, or it's something you calculated at enormous length, and then you want to check, is it equal to something else? In JavaScript, there's also a symbol with 3 equal signs, like this, which at first glance seems to do the same sort of thing, and we're going to be looking at that a video or two down the line. For the moment, we'll just look at equals. Now let's just copy this, and I'll add like a sort of a bit of text here, so that we can, because I'm going to have lots of these, I want to keep track of which one's which. Okay, so there's equals. There's also less than or greater than. So we could write days in week less than 8, for example. That will be true. Let's try this. True. And there's also greater than, so days in week greater than 8. So of course this is the bit that's being actually evaluated and turned into either true or false. This is just some text that I've just put there as a description. So is days in week greater than 8? No, it's not, because days in week is 7. So if we run this now, we should get false, and we do false. You can use less than and greater than with floating point numbers like 8.3, for example. If you want to compare two numbers with decimal points in them, you can compare them with greater than or less than. You can't do it so successfully with equals. It should be avoided. Don't try to compare floating point numbers or decimals or fractions, whatever you want to call them, with equals, because they can't be stored in a precise way in a computer's memory. So two floating point numbers that seem to be equal, they could differ by some tiny amount, and they won't be equal at all, or something weird could happen. Basically, just avoid comparing floating point numbers with equality test operators in most programming languages in general. It's not a good thing to do. But all of these work fine with integers, and it's common to use these two with floating point integers. Notice with the less than and greater than operators, they return true if the thing at the smaller end of them, if you think of them as having a small end and a large end, these actual operators, it's when the thing at the smaller end is smaller than the thing at the larger end that they return true. So days in week, is that smaller than 8, which is at the larger end? Yes, so that's true. Here we've got another operator, it's greater than. Days in week is at the bigger end of the operator, so to speak. Is that bigger therefore than 8, which is at the smaller end? No, it's not. So this is going to evaluate to false. After a while, it sort of becomes second nature to recognize these less than and greater than. So we've also got greater than or equal to and less than or equal to. Let's copy these and change them to less than or equal to and greater than or equal to, less than or equal to, greater than or equal to. So taking this one for a start, less than or equal to, this is going to return true if days in week is either less than or equal to 8. Let's maybe put 7 here. So if we ask firstly, is days in week less than 7? That's false. It's not less than 7 because it's equal to 7. But if I write, is days in week less than or equal to 7, less than or equal to 7, that's now true. Days in week is less than or equal to 7 because it happens to be equal to 7. So if I run this now, I should change the text as well here. This is now true. And greater than or equal to, of course, works in the same sort of way. I'll just leave this as it is. Is days in week greater than or equal to 8? False. It's not greater than 8, and also it's not equal to 8. And that's why that gives me false. There we go, false. Okay, so those are all the most important comparison operators for numbers. We've also got this one, the identity test operator, which we're going to talk about later. But, in general, you can basically use that instead of equals wherever you feel like it. With numbers here, it's just going to do the same thing. Oh yeah, there's also not equal, which I should mention. So if I copy these, we've got, looks like this, and we've also got a version of it with just another equals sign in, which for our purposes here does the exact same thing. So is days in week not equal to 6? That's true. It's not equal to 6. So if you run this, we find, yes, it's true that it's not equal to 6. And this longer version does the same thing here. We'll talk about that later. So if you're a beginner, and you probably are if you actually watch this video, then you want to just practice these. Try them all out for yourself. Just try them all out. Don't worry about making notes, but try them for yourself. And you probably want to make sure that you can remember what they're called, I suppose. So this is equality test. This is actually identity test, which we'll look at later. This is the not equal operator. This is not identical. And we've got less than. What's this one? Greater than. less than or equal to, greater than or equal to. Okay, try them all out, and we'll move on to look at comparing strings. When we finish going through these comparison operators, which won't take us much longer, then we will go on to actually practically using them and looking at some more of the building blocks of programming. So until next time, happy coding. Hello, in this video we're going to talk about basic string comparison in JavaScript. So let's use strict here, and I'll have a string. Let's write text equals cat. So we can check if two strings are equal with equals equals. So let's write console.log and text equals cat. So these two strings are equal. So this equality test operator here should return true. Let's maybe put this in a kind of a comment. We'll just output this text so that we know what we've done here. Then if I run this, so node and comparing strings.js, we see that this indicates that the two strings are the same by returning true, or by evaluating to true. We can also use the slightly longer version of this operator. So that's the equality test operator. This is the identity test operator. What's the difference? Well, we'll look at that in the next video. But in a nutshell, basically, some people think that you shouldn't use this short version. It's kind of an older feature of JavaScript here, this equals, and some people call it the evil twin of the identity test operator. So if in doubt, use the longer versions. So if you run this now, again, that says they're the same. It returns true. We've got not equals as well. So we've got, that also works with strings, just as you'd expect. So is it true that this text, which contains the word cat, is not equal to cat? That's going to be false in all of these cases. Not equal, and it's false that it's not equal. It's false that it's not identical. It is identical. It is equal. Now, surprisingly, we can also use less than or equal to with strings. So we can write text, for example, this variable text, less than dog. Is that true or is it false? Let's maybe just put this in a comment as well. Not exactly a comment, but just some text to remind us of what we're doing here. Well, this is actually going to evaluate to true, because it just checks the alphabetical ordering of the strings involved. So cat sorts earlier in the alphabet than dog, because it begins with a C. So if you think about the ordering of it, it's true that cat is less than dog. So if I run this now, it's not a comment on cats or dogs, but it says true. Cat is less than dog in the alphabetical sense. So of course you can use greater than, you can use greater than or equal to with strings as well. Let's just check that. So I could write text greater than or equal to dog. Is it true or is it false? Well, cat it sorts earlier in the alphabet than dog, so that's going to be false. What else? I think that's probably it. Less than, greater than. Notice that the less than or greater than are sort of case sensitive. So here we've got, let's try comparing cat with a capital C, or dog maybe. Let's write dog with a capital D, and I'll just replace the text in this string here as well. So is this true or false, that dog is greater than or equal to dog? It's false, I think, because in the character set that we're using here, Unicode character set, capital letters are actually ordered earlier than lowercase letters. So I think this is false. Let's just try it. Yeah, false. So dog is not greater than or equal to dog with a lowercase d. All right, that's it for this video. There are other ways to compare strings as well, but most of the time these operators will do the trick for you. So until next time, oh yeah, if you're a beginner, the important thing is, I'll just say it again, you've got to just try this out for yourself. Try them all out and make sure you understand them. And pretty soon we're going to get on to practically using them with loops and conditionals. We're still working at the moment with the absolute nuts and bolts, the real building blocks of programming languages. So until next time, happy coding. Hello, this is John from caveofprogramming.com, and this is another video in my series on JavaScript and Node.js for beginners. In this video we're going to take a look at the identity test operator. Then in the next video we'll talk a little bit about the history of JavaScript, and following that we're going to get into actually using these for some basic nuts and bolts programming, that is using the kind of equality test operators that we've been looking at. So as always, I'm going to start with writing use strict. Doesn't matter if I use single or double quotes, and that forces me to declare variables. And let's have a variable called days, which I'll set equal to 7, and we'll write console.log and 7 equals 7. Let's write days equals 7. So of course this will give us true. Actually, I'm going to use the terminal here that's built into Visual Studio Code, because that's probably easier than switching to another external bash terminal all the time. If I go to the view menu here and terminal, I can open a terminal. Okay, so if I write node and the name of my file, this gives me true. Now there's also a equals operator. Let's first actually put this in double quotes, just so that I can keep track of what I'm doing here with a sort of a comment. So there's also a version of this operator that has 3 equal signs, and we can call that the identity test operator. And in this case, it does the same thing. It gives us true in this particular case. Now the difference is that equals will do all kinds of type conversions to try to ensure that you get what it thinks you want, whereas equals is a stricter kind of operator. It tests not only equality but also type. You can think of it as an identity test operator. It won't do any conversions. So you see the difference if you put the 7, let's say, in quotes. So if I put a number in quotes, it becomes text. Now equals will actually convert this text to the number that it seems to represent. It helpfully does this conversion for me, and it will give true here. Let's try it. So you can see true. The identity test operator with 3 equal signs gives me false, because it doesn't do any conversion. So it says, is days, which is a number, equal to 7? Is that equivalent or identical to the text 7? And the answer is no, because okay, they might both represent the number 7 in one way or another, but the fact is this is text and this is referring to a number, so they're different things. So this is the equality test operator, and this is the identity test operator. And the identity test operator, it will not helpfully convert one thing to another to try to get at your meaning, or to put it another way, it will test both whether two values are equal and also whether they have the same type. And if they don't have the same type, it's going to tell you false. So it's a stricter operator. There's also a not version of this. So if I were to write not here and also, so not equal here, and here we've got not identical, and let's just change these comments here. What are these going to give me? What about this one? Will this return true or false? Well, is days, which is the number 7, is it not equal to the text 7? That's the question. And in this case, I would say, well, that's false. They are equal. Okay, one's text and one's a number, but this single equals version of the equality test won't worry about that. It will convert them. It will convert one thing to another. So it's as if we're doing 7 not equal to 7, and that's false because 7 is equal to 7. Whereas this will give us true. 7 not identical to the text 7. That's true. They aren't identical. Let's just prove that that is the case, and I'm not lying to you. So the first one is false. 7 is not equal to the text 7. It's false because they are equal. And second one is true. So of course these two are just flipping what these two are doing. So here we get true and false, and here we get false and true. All right, so if you're happy with that, then do feel free to move on to the next video. If it's puzzling though, then please do try this out. Especially if you are literally a complete beginner with this, try it out for yourself and try to get your head around what's going on here. It's a really good idea. And in the next video, I'm going to talk a little bit about some relevant history here, which might help explain why we have two different operators for testing what seems like equality. Okay, so until next time, happy coding. Hello, this is John from Cave of Programming, and this is another video in my JavaScript and Node.js for beginners tutorial. And in this video, I just want to talk a little bit about the history of JavaScript. So I looked up when JavaScript was actually devised and created, and apparently it was about 1995. So I started, as far as I remember, I think the first web page that I actually created would have been 1997. And I started looking at VB script at the time and JavaScript pretty soon after that. So I think I started using JavaScript fairly soon after it actually came out. Now, in the last video, we looked at this identity test operator, and I don't remember that identity test operator being there in the early days of JavaScript. I couldn't actually find out about the history of it in the 10 minutes I spent searching. I didn't manage to find out when it was added to JavaScript. But I don't remember it being there. If it was there, I don't think many of us used it, that's for sure. But I think it was added to JavaScript quite late on. Now, JavaScript, when it first came out, was a scripting language that was intended to add a little bit of functionality to web pages. So you'd write a web page in HTML, a kind of tag-based language that we'll look at a little bit later on in this course. And that represents, how your web page looks. And then in the early days, sometimes you wanted to add just a little bit of functionality to your website. And typically you'd be either creating an image rollover, which were popular in the past, and that's where you moved your mouse over an image and it changed when your mouse moved over it. Or you'd be adding some validation to a web form. So you'd have a form people could enter information in, and you wanted to make sure that they could only enter information that was appropriate, like that they didn't type letters into a telephone number field or whatever. And of course that's not ironclad validation. A hacker could get around it, but it was and is helpful for the average web user. So JavaScript was at first used for that sort of thing, and typically nothing much more complicated than that. So it would have been strange under the circumstances if JavaScript continually forced you to convert one thing into another. Like the value that you get back from a form in on a web page, is that coming back as text or as a number? Probably text. And then if you want to compare it to a number, you don't want to have to convert it. So the equals operator was implemented generally to be extremely flexible in JavaScript. But what's happened, I think, is that as JavaScript has moved towards being a general purpose programming language, then this equals operator, equality test operator, has just been felt to be too flexible, too helpful, and we have this stricter identity test operator has been added to JavaScript. And in fact, I think some people say that the equals operator is now the evil twin of the equals operator. So they say that you shouldn't use it unless you really absolutely need it. And I concur with that, really. I think now use the identity test operator with 3 equal signs wherever possible, and generally avoid using the equals or the, for that matter, the not equal. Prefer the version with more equal signs, because it's a stricter test and it doesn't do unnecessary conversions. And these conversions, you might sometimes find it a bit hard to even predict what they're going to do. You know, it's letting the language get out of your control a little bit. It's better to use something stricter so that you're sure of what's actually going on wherever possible. Now, the path from a sort of lightweight, silly little programming language used in browsers to a general, powerful programming language has been a long and hard one for JavaScript. The problem was that in the early days, every browser had a different implementation of JavaScript, and in fact, things that worked in one browser didn't always work in another, and that is still a little bit of a problem, but much less of a problem than it was in the early days. And often now we're not even writing JavaScript in a browser. You know, here I'm starting off this course, we're doing it on the command line to start with. But that was an obstacle to improving JavaScript, because if someone, let's say the people who are in charge of Internet Explorer, which was for a while a very popular web browser, if they added some new innovation in JavaScript to their browser, the people who were in charge of the Netscape browser or whatever, they didn't necessarily add the same thing, so it was just a mess. And what was one early attempt to kind of paper over the cracks was people created sort of JavaScript APIs or libraries like jQuery, which give you a sort of common interface that papers over the cracks. So you use jQuery. It's still very useful today, and it can do much more than just papering over cracks. But one thing it does is it gives you a kind of standard interface that works the same on all browsers. You work with jQuery, and it kind of works with JavaScript behind the scenes. It is just an addition to JavaScript, but it makes JavaScript a bit more seamless. And there are also things like CoffeeScript that sort of compile to JavaScript, and again give you a sort of uniform way of dealing with JavaScript. But what was really needed was a kind of universal language standard for JavaScript, and that developed in the form of this thing, ECMAScript. ECMA stands for something like, what does it stand for actually? Let's take a look. I don't want to tell you the wrong thing here. ECMA. Take a look here. ECMA stands for, it's not going to tell me, is it? Manufacturer something, computer manufacturer. All right, let's just type this into Google. What does ECMA stand for? I thought it was European, but I didn't like to say, because I was thinking, European, really? Usually this stuff comes out of the States. Okay, but European Computer Manufacturers Association, incredibly. So this ECMAScript is a standard for JavaScript essentially. It's not a language in itself, it's a standard for a language. And we can see, okay, the 4th edition was abandoned, but the 5th edition came out at some point, and that kind of took. And then, we see major progress around, sort of like 2011, 2015, and so on. You can see that, add strict mode in 2009. So anyway, now this has kind of changed the dynamic that's going on here, because now people who implement JavaScript in a browser sort of are going to have to pay attention to this ECMAScript standard, and hopefully they'll all implement the same thing. So it's a big step forward to creating a unified, coherent sense of what JavaScript is that will be supported by all major implementations. And I guess it probably helps as well that at the moment the Chrome browser is dominating the scene. So what Chrome does, other browsers are going to have to play catch up with. So now we've got this unified standard for JavaScript, and a part of it added, I think, in maybe 2011, but I'm not sure, don't take my word on that, is this equals 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 operator that helps make it a more strict sort of a language. Okay, so I just wanted to talk about this a bit. In case you wonder why 3 equals signs just to check equality. And also, it's important to know about this ECMAScript standard. A single equals sign is used to assign values, of course. Equals equals, 2 equals signs, that was used to check equality, but that was felt unsatisfactory. And now in this ECMAScript standard, we have this identity test operator with 3 equals signs. Hopefully there's not going to be one with 4 equals signs. That would just be too much. All right, so that's it for this video. Until next time, happy coding. Hello, this is John from caveofprogramming.com, and this is another video in my series on JavaScript and Node.js for complete beginners. So in this video, we're going to take a look at the if statement. If you've done any programming before, this will be probably too simple for you. And if you are a complete beginner, this is for you. So if you have done some programming before, you probably want to skip ahead in this course a little bit, maybe to the bit where we start discussing objects and classes. I'll see how the course goes. I haven't created those videos yet at this point in time, but by the time you watch this I may have. Okay, so I've created a file here called conditions.js, and I'm going to just write use strict here, semicolon. You may have noticed, if you've been following this course, that often in JavaScript it will work just fine without the semicolons, but I feel it's good practice to put them in. Occasionally they are absolutely needed, and other times JavaScript will just kind of automatically kind of put them in behind the scenes, so it will just infer that you meant a semicolon. Semicolons are used to end statements, basically. It's the kind of programming equivalent of a full stop, or a period, as you say in the USA. But because JavaScript was used for such a long time in browsers, it's kind of got this free and easy thing whereby it will try to correct your mistakes to a certain extent. Okay, so let's get a command line argument, and we'll say that that's going to be a temperature. So let's write let temperature. So I'm declaring a variable, and I'm going to assign it the value of process.argv2, which, if you've been following this course, you might remember is how we get the first thing that someone types after the name of the program when they run it. So in other words, it's the first command line argument. And then let's actually just echo that back just to see it. So let's print it. So if I run node conditions.js, it says undefined. But what I can do is, after the name of the script, I can write, for example, 21, and then it's going to echo that back to me now. Console.log is printing what I just typed. So supposing we've got some sort of heating system, and we want to take some kind of action if the temperature is, let's say, below 20. So we imagine that what I'm typing here is the temperature in Celsius. And if it's 20, if it's below 20, it's too cold and I want to turn the heating on. I can do that with an if statement. An if statement looks like this. So I'm going to write the keyword if, then I'm going to have two round brackets, and I'm going to have two curly brackets. And notice I've put the opening curly bracket on the same line as the if and the round brackets. And then the closing curly bracket goes on a line further down, and it's kind of aligned with the if. They sort of line up. I'm following the most common coding convention in JavaScript here. There are others, like some people put this bracket down here, but that's less common, I believe, at the moment now in JavaScript. So I'm going to follow the most common formatting for this, and it is important to follow a convention for your code formatting. It's very important. Now, in these round brackets, I can put a condition. So, for example, temperature less than 20. And I can put code in these curly brackets, which will only be executed if this condition is true. So let's just output some text there with console.log. And I'm going to print activating heating. Run this now. If I put 21 there on the command line, it's not going to do anything. If I put 20, it's still not going to do anything, because I've said do this only if temperature is less than 20. So 20 is not less than 20, it's equal to 20. Let's run it with, for example, 19.5. And now it says activating heating. So this is an if statement. Hopefully it's fairly clear what it does. It will run the code in curly brackets only if this condition in the round brackets after the if keyword, only if that's true. We could put another one in there. Let's just copy that and put another one in. And we can say if temperature is greater than 21, let's say deactivating heating. So now, if I run this with, let's say, something less than 20, it's going to say activating heating. For 20, it does nothing. 21, it does nothing. But if I type in some value above 21, like 21.2, it says deactivating heating. So now it's too hot, switching the heating off. So these are just a very couple of very simple if statements. And if you haven't seen these before, it's really important to practice them. In the next video, we'll look at more complicated versions of these if statements. And we'll leave it there for this video. Do try that out if you're a beginner especially. And until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at if-else in JavaScript. So I'm continuing here my series of videos for complete beginners on JavaScript and Node.js. And in the last video, we looked at if statements. We looked at this. So I would suggest typing this out and getting it working before you tackle this video. And we saw that with an if statement, it will execute code conditionally. So this if statement will only run what's in these curly brackets if this condition is true. And the same for this one, of course. So what we've done here is created something which will say activating heating if the temperature supplied on the command line is less than 20, and it will say deactivating heating if the temperature is greater than 21, otherwise it will do nothing at all. Now we can combine these into a single statement because the fact is that it's not very efficient to have two separate checks like this on temperature because if the temperature is less than 20, then if this is true, there's no need to then check if it's over 21. If it's less than 20, it can't be over 21, and yet here we are, we're checking it again. So we do this check and we find it's less than 20, So we run this when we say activating heating, and then we're checking it again. Is it over 21? But it can't be. So we can combine this into a more efficient statement. Before the second if, we write else. So we have else if, and we move this up to get rid of the blank space here. And now we've got a single if else if statement. And the way this works is if else if is going to execute one of its alternatives and only one. But it doesn't bother doing unnecessary checking. So now, if we find that the temperature is less than 20, it won't bother checking this because there is no point. If else if will only execute one of these two alternatives, if either of them at all, and it's a question of which one. So this works kind of like the program that we had before, except it's very slightly more efficient. If I type something above 21, it says deactivating heating. And if I type something below 20, it says activating heating. And if I type something in the middle, like 20.5, it just doesn't do anything at all. It just finishes. All right, now we can make this even a bit more complicated because I could write on the end else. Let's put it in the right place though, else. And this is something that will be executed if none of the alternatives above were executed. So let's write console.log temperature is normal. So if none of the conditions above it are executed in a sort of compound if-else if statement like this, else will be executed. That means that in this statement, we're always going to execute one of these three alternatives. The question is only which one. So, JavaScript's going to start reading this from the top down. So the first one that it finds that matches, it's going to execute that one and only that one. And if it goes all the way down and gets to the else and finds that none of the above conditions have been executed, then it will execute the else. So now the difference is if I type in 20.5, which doesn't trigger either of these two conditions, then it says temperature is normal. If I were to put 19, let's say, activating heating, and 30 would be deactivating heating. You can have multiple else if clauses in here. So I could put another else if in here, and I could say if temperature is greater than 30, let's say room is overheating, danger. Let's maybe put 35, that's really quite hot, at least where I come from. And it works as you'd expect. So if I put 30 in there, that triggers only deactivating heating. If I put like 40 in there, that's going to say, yeah, well now we've got a problem because if I put 40 in there, then this is going to get executed first. So JavaScript will read this down from the top, and it comes to here and it says, okay, you put 40 in, so this condition is true, the temperature is greater than 21, and it runs this, and then it won't run any of the others, because with this if-else if statement, you're only going to be running one of these clauses, only one of them. So in this case, I can never actually execute this. But supposing I move that up, so I'm going to hold down the Option key and use the arrow to move it up. Got to pay attention to formatting here. Now I can run any of these different clauses. So now if I run the program with a temperature of 40, it's going to say room is overheating, danger. If I run it with a temperature of, let's say, 30, it just says deactivating heating. So hopefully you can see why that works and why it didn't work when I put 35 down where 21 is, because it's going to read from the top. It's going to say, is this true? You have to remember it's only going to do one of these things. is this true? And if not, it will take a look at this. Is this true? And if not, it will do this. As soon as it finds one that's true, it will execute it. And if none of them are true, it's going to execute this. So if we were to put in here, like, what's the normal temperature now according to this? 20.5. That says temperature is normal. Okay, so if you're a beginner, definitely try this out. This works the same in a whole bunch of programming languages. It's the same in Java, C, C++, a whole bunch of others that I can't even really remember. But it's a really common sort of construction. And yeah, so try it out for yourself and experiment with it a little bit. And then we're going to move on soon to looking at loops. And in this bit of the course, we're just really looking at the absolute most important nuts and bolts of programming, which are, by the way, generally either the same or extremely similar in a whole variety of different programming languages. There are some languages that they do have this if, else if type of idea, but they just have slight spelling variations in there. Like in Perl, if I remember rightly, Perl Practical Extraction and Report Language, you would write elif there instead of else if. So you get minor variations like that. But generally, even programming languages that don't use the exact same spelling for all the keywords, they have a lot of these constructions in common. And you will usually find in a programming language some way of doing this if else type of construction. All right, so until next time, happy coding. Hello, this is John from caveofprogramming.com, continuing the series of videos in my JavaScript and Node.js for Complete Beginners course. In this video, we're going to start looking at loops in JavaScript, and we're going to look at the very common while loop, which is a kind of loop. So I've created this file while.js. And if you are a complete beginner, this is a kind of exciting step, because when you start using loops, that's the point at which you really leverage the power of programming to automate things. So instead of typing something in your code like 5 times or even 50 million times, which would be really impossible, nearly, you can get the JavaScript interpreter to output, let's say, some text or to execute some code as many times as you want. Let's start off by writing use strict. Doesn't matter what kind of quotes I use, double or single, but I'll try to use single because I actually think they look nicer in JavaScript. So the first thing we need is a variable, so we're going to execute some code repeatedly, and we need to keep track of how many times we've run that code so far. So I'm going to create a variable called counter. Let's write let counter equal, and I'm going to initially set it to 0. And then we're going to write while. So while is a keyword, and after that we have a pair of round brackets, and after that I'll put a space in because I think it looks nice, and we open a curly bracket, and Visual Studio Code has actually put the closing curly bracket in for me. I just hit return, and that lines up with the left margin, which is exactly where we want it. So we want a construct that looks like this, and you may recognize this to an extent even if you're a total beginner, because it's the same as what we have for an if statement. And as with an if statement, we're going to put a condition in here, and we're going to put some code between these curly brackets here. These curly brackets and the code inside them that we're going to put inside them, that's called a code block. So let's suppose we want to output some text exactly 3 times. We can write here while counter less than 3. And within the loop, we're going to increase the value of counter. So I could write counter equals counter plus 1. Now every time this executes, it's going to increase the value of counter by 1. And this sometimes confuses beginners because it looks like we're saying counter is equal to counter plus 1, which seems impossible unless counter is infinite, I suppose. Maybe then it's possible, I don't know. But you have to remember that this is the assignment operator. What it does is it takes whatever is on the right-hand side and it assigns that value or stores it in this variable on the left here. So we're assigning a new value to counter, which is equal to counter plus 1. So if counter is 0, then 0 plus 1 gives us 1, and it stores that value in counter, so the new value of counter becomes 1. We can actually write this in a shorter way just by writing counter plus plus. It does the same thing. It increments the value of counter. It adds 1 to it. So what does this whole thing do? Let's first put in some text. So we can, before we increment counter here, we can put in as many lines of code as we want, and they will be executed repeatedly. I'll just put in some blank lines just to make it a bit clearer. Let's write console.log hello semicolon. So the JavaScript, or the Node.js interpreter in this case, is going to read down, we declare counter, and then we hit this while keyword, and it says, okay, is this condition true? If it is, then it's going to execute whatever is in this code block here. When it's finished executing it, it's going to go back to the beginning, go back to the while keyword, that is, and it will ask again, is this condition true? And if it is, it will execute the code block again. It keeps doing that until it finds that the condition is false. When the condition is false, it's no longer true, then it won't execute this. It will go on to whatever is after that in the program. Let's write console.log finished. And this may seem confusing if you're a beginner, but the thing is to try it out and play with it a bit yourself. So let's run it now. I'm going to write node while JS, and we see we've got 3 hellos exactly, and then it says finished. So if you just practice this a little bit, you should be able to figure out how to output some text exactly the number of times that you want. Notice it's not going to work if we don't increment counter here. That's a vital working part of it. It's quite common to forget that. So when you're writing while loops, I recommend putting that in right at the start before you start filling in code that you want to execute in the loop. If we comment this out here and I try to execute it, I haven't actually tried this, but let's try it. Then it's an infinite loop, and I have to stop it with Control-C, which stops programs executing in the bash shell. So we don't normally want infinite loops. Well, we always have to have some way of ending the loop normally. So you have to remember all the different bits of this. So it can seem a bit counterintuitive that we're saying while counter is less than 3, and yet we want to output, or we want to execute whatever code is in here 3 times. And the reason for that is that counter starts at 0. So we have 0, 1, and 2. Those are the iterations of the loop, the values of the counter for those iterations. So to sort of show what I mean here, if I write comma counter in console.log so that we output the value of counter, I'll just clear my console. If I run that, we can see that counter takes the value 0, 1, and 2. And then when it gets to the value 3, this condition is false. Counter is no longer less than 3. It's false. So it doesn't execute that. It just goes on and does the rest of the program afterwards, as you can see. So if you're a beginner, you definitely need to practice this a little bit. I'm going to give you an exercise in the next video, but you have to. I would recommend practicing this before you go on to that video, because otherwise the exercise it may be too hard. Practice it a little bit. It's really not difficult. It can look confusing at the start. You just need a little bit of practice with it, and you should be able to output whatever text you like exactly however many times you like. Okay, so we'll leave it there for this video. Until next time, happy coding. Hello, this is John from caveofprogramming.com, and this is another video in my Node.js and JavaScript for Complete Beginners course. In this video, I'm going to give you an exercise. and I'm going to give you some tips and suggestions for how to tackle the exercise and how to tackle like programming tests in general. So if you're a like seasoned programmer in another language, this might be too simple for you, but if you're a beginner, it might be too complicated, but I'm going to, as I say, give you some tips for dealing with it. So let's go to a browser, and I'm going to search for the Leibniz approximation of pi. So Leibniz was a kind of mathematician, physicist. I think he was Dutch, and he found a way of approximating the value pi. Now pi is just a number, it's a floating point number, and what we want to do is find an approximation for it. So pi itself has digits that go on forever, like it's an irrational number, so we can't write it down precisely, but what we can do is approximate it, and we can make a value for pi that's as accurate as we want it to be. Before we take a look at this, let's go back to our code here, and I'm just going to start my program with use strict. I'm going to write console.log, and if we write math.pi, capital letters, math.pi will is actually a value, an approximation of pi. So it kind of shows us what we're aiming at. Math here is what we call a class, and we'll look at those later. Pi is a constant. So if I run this program, let's write Node and pi.js, we get this value 3.14159. What we're trying to do is produce this value approximately. So we want to get it right to at least some of the initial digits. It is literally just a value. And we can do that using this formula. So we start with the value 1, which notice is the same as 1 divided by 1. And then we subtract 1 divided by 3. And then we add 1 divided by 5. We subtract 1 divided by 7. And we keep doing this. Let's say if we do it for maybe, I don't know how many, 1,000 or 5,000 terms, eventually we'll get a value that's equal to a quarter of pi. So if we then take that value and multiply it by 4, we should get a reasonable approximation of pi if we've done this, you know, like, I don't know, 5,000 times. So how are we going to tackle this program? Well, if you feel confident and this doesn't look too off-puttingly difficult to you, then do pause the video and have a go at it. I'm going to show you how to actually write the program in the next video, but we're going to look at how to tackle it here. So the thing is, when you have some kind of test that you have to do with programming, I think the thing is to tackle whatever bits you can do. So you know now how to create a hello world program in JavaScript. That bit you can do. You can already do that. So I would say already do that. You know, there's no need to think about how to do the whole thing necessarily in advance. Just do the bits you can to start with. And then we can start breaking this down. Well, what do we need here? Well, we need a series of numbers, which if we think of the first one as being 1 divided by 1, we need these numbers on the bottom here. So the question is, can you write a program that outputs the numbers 1, 3, 5, 7, 9, 11, 13, and so on? Because if you can do that, you've taken a big step towards it. What we also need is we need to take 1 and divide it by each number. So if you can write a program that outputs 1, 3, 5, 7, 9, and so on, it's not too hard to write a program that outputs the values 1 divided by 1, which is 1, 1 divided by 3, 1 divided by 5, 1 divided by 7, and so on. That shouldn't be too hard. And then there's this tricky bit. We've got to have alternating minus and plus signs. So what you could do is take each of these values and multiply them alternately by 1 or minus 1. So then the question becomes, can you write a program that outputs 1 minus 1, 1 minus 1, 1 minus 1, and so on, alternating? And you could do that by taking a variable, setting it equal to 1, and in your loop multiply it by minus 1 every time you go through the loop, because 1 times minus 1 is minus 1, minus 1 times minus 1 is 1, 1 times minus 1 is minus 1. Multiplying by minus 1 will cause your value initially set to 1 to alternate. So I'm going through this a bit fast, but that will give you all the building blocks that you need here. And what you'd need to do after that is you need a variable that can just accumulate all those values. So you take your 1 or minus 1 and multiply it by a third or a fifth or whatever you're outputting at that point in the loop, and just add those values to your variable every time you go through the loop. Then at the end, take that variable, multiply it by 4, and you should get a value for pi. So especially if you really are a beginner, have a go at this and write whatever bits you can. Break it down in the way that I've just specified. Break it down and see what bits of that you can write. If you can even write a program that outputs 1, 3, 5, 7, 9, 11 and so on, adding 2 every time, then that's really a good step. So I think the thing is, you learn a tremendous amount by trying to write programs. In a way, it doesn't much matter what you try to write. As long as you keep trying to write programs, your programming ability will improve. And this is just one suggestion of something you can do. And if you try to write it, even if you don't succeed in the end, then you'll get some really good practice, I think, by doing this. You know, so just have a go at it and see if you can break it down into different bits. Output values as you go along. That's a really important thing, and see if you're on the right track or not, and see where you get with it. And in the next video, I'm going to show you an example implementation of this. We're actually going to write this program. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. This is another video in my JavaScript and Node.js for Complete Beginners course. And in this video, we're going to tackle approximating pi. So we're going to do the exercise that I gave you in the last video. So the first step, as we've seen, is we want to get these numbers on the bottoms of these fractions here. So we can think of the first term. So these are we call them terms of the equation. Oh, by the way, I want to mention that people often ask, do you need to know a lot of mathematics to do programming? And the answer is no. I've picked a mathematical example, but you could have a career in programming, and this might end up being, in a way, the most mathematical thing you ever do. You know, so don't be put off by the idea that programming is mathematics, because it isn't. But anyway, you can think of this first term here as 1 divided by 1. And that will help, because then the numbers on the bottom here are 1, 3, 5, 7, 9. So the first step is, let's see if we can write a program that outputs the values 1, 3, 5, 7, 9. And if you had a go at this and you didn't manage to do it, then do feel free to stop at any point and implement whatever bit of this you think you might be able to implement. So we're going to need a loop. Let's leave that console.log math.py in here. But I'll move it to the bottom, and actually I'll comment it out. So in other words, if I put 2 slashes at the beginning, that turns the rest of the line into a comment, which is useful for documentation, but it doesn't actually do anything in terms of your code. So that's quite a useful thing to do. And we call this commenting something out, where we temporarily turn it into a comment and deactivate it. Okay, so if I've got a loop, I'm going to need a counter. Let's create a loop counter and set it equal to 0. And then I'll have while counter. Let's put less than 5 initially, just some small value while we're developing this. So I've got my brackets and I write counter plus plus. But there's nothing in the loop. So now let's maybe create a value, which we'll create a variable which we're going to add 2 to every time. So the variable is going to have values 1, 3, 5, 7, 9, and so on. So I'll call this, well, since this is going to end up on the bottom of our fraction, and that's called the denominator, I'm going to call this denominator. Denomals 1 to start with. 1 to start with. Then in the loop, I can add 2 to that every time. So denominator equals denominator plus 2. Now if we output it down here, the first value that we see will be 1 plus 2, which is of course 3. But if we output it here, above where we increase the value of it, the first value will be 1, which is what we want. So let's write here, in fact I'll put these two lines together because they're kind of similar. Console.log denominator. Alright, and let's run this and see if we've succeeded so far. So Node.js, and we see we've got 13579. That's exactly what we want. Now the other thing that we need here is, so we need to form a fraction, and we could do that step next. Let's just do that. So instead of outputting 13579, we need to output 1 divided by 1, 1 divided by 3, 1 divided by 5, and so on. And that's pretty easy to do. So all we have to do is change this to 1 divided by denominator. And if we run this, we've got 1 divided by 1, 1 divided by 3, or a third, 1 divided by 2 is a half. 1 divided by, what am I talking about? This is 1, that's 1 divided by 3. This is 1 divided by 5, 0.2. 1 divided by 7, 1 divided by 9, and so on. So so the different bits of an equation, like in this case 1, a third, a fifth, and so on, they're called terms in the equation, just in sort of mathematical language. So I'm going to write here, let term equal. So we'll store that in a variable for convenience. And we can output that if we want. And our program, the output of it is unchanged. There we go. All right. So now the next thing that we need is, we notice that we've got this sort of sign alternates here. We've got to add on, we've got to subtract a third, add a fifth, subtract a seventh. So we could think of this as being like we're always doing additions, but what we're doing is we're adding minus a third, and then we add a fifth, and then we add minus a seventh, and so on. To get these alternating plus and minus signs, we can create a variable which we multiply, which starts off at the value 1, and we multiply it by minus 1 every time. So let's try that. So I'm going to call this variable sign and set it equal to 1. And then here, where we're sort of changing values of things, I'm going to write sign equals sign times minus 1. And then let's output that. So instead of outputting term here, I'll output sign. And that should give us an alternating 1 and minus 1. Let's run it. So now, if we take our term and multiply it by sign, we should get 1 minus a third, and then plus a fifth, and then minus a seventh, and so on. So let's write let term equal sign times 1 divided by the denominator, and then we'll output term again. We'll try this. Minus a third, we've got plus a fifth, we've got plus a fifth, we've got minus a seventh, plus a ninth, and so on. And that's exactly what we want. Now all we have to do is add all of those up, and at the end multiply them by 4, because this gives us an approximation for pi divided by 4. So we're going to have to multiply it by 4 at the end to get pi. So let's create another variable. Let's call it sum, set it equal to 0. And then what we'll do is every time we go around the loop, I'm going to just say sum equals sum plus term. Should get closer and closer to pi. After the program's finished, closer and closer to pi divided by 4, that is. So, sorry, after the loop, not the program, after the loop's finished, we can then write let pi equals sum times 4, and we can do console.log pi. And then let's uncomment this console.log math.pi so we can see how close our pi is to the actual pi. Let's try it. So at the moment, not very close. We can see it's in the right sort of area, but the thing is we've not added on enough terms to get a sort of realistic value for it. Let's try 1,000. And then if I run this, we get, it's pretty close now. Pretty close. Let's try 5,000. And this will still execute in the blink of an eye, even on an old computer. And we can see that we're getting closer. The first few digits are correct. Maybe try 20,000. So 14159 doesn't go wrong until here. So 14159 doesn't go wrong until here. And you can try more if you want, like you know, like a million or something. How many is that? Let's take a look. So 1, 2, 3, 1, 2, 3. That's 1 million terms. And if we run that, yeah. So you can see that the more terms you add, the closer it gets. The more terms you add, the closer it gets to pi. It's a kind of known downside of the Leibniz approximation, that it doesn't converge to pi very quickly, meaning you have to add a lot of terms to get a value that's accurate for more than a few digits. But you can see that this is basically working, and if we were to go on and add more and more of the terms in our equation here, we will get exactly what we want. Now we can write this program a little bit more nicely here. So if I was writing this not for explanatory purposes but just for myself, I would have condensed this more. I wouldn't have put probably term in a separate variable, for example. I would have just written it down here and so on. But one simple thing that we can do is we can use a slightly different operator at certain points here. So instead of writing sum equals sum plus term, we can write sum plus equals term. And the plus equals operator will just add on whatever's on the right to the existing value, the existing variable value on the left. So this means sum equals sum plus term. Sum plus equals term, we're just adding term to sum every time. And we can do the same with times. Instead of writing sine equals sine times minus 1, we can write sine times equals minus 1. It's kind of something that can make your code look a lot nicer. Here's a simple example. Instead of denominator equals denominator plus 2, denominator plus equals 2. And if this seems confusing, just practice it in a really simple program. Don't use a loop, just take a variable and try using plus equals and times equals just to see what they do, and you'll find that they're actually really not so bad at all. So I think that's it really for this video. Let's just try this and check that it still works. Yeah, it's still fine. And you could simplify it in a way just by not having a separate variable for term. So I mean, you could take this and put it down there, rather than storing it in a variable. Say sum plus equals sine times 1 divided by denominator. Okay, so we'll leave it there for this video. If you just found that too complicated, don't worry at all, and you're not going to need mathematics knowledge here. Most of programming, it's about logic, and you learn the logic at the same time that you learn programming. It's not really about mathematical approximations, unless you're working in that kind of a field, a sort of mathematical field. So if you found the exercise too hard, don't worry at all. It is just an exercise, but the important thing is to try to do these things. Do whatever bits of them you can. And if you didn't try to do this exercise, make up some exercises of your own, just whatever you can think of. It doesn't matter even if they're ridiculously simple. They don't have to be something like really serious sounding, like some serious mathematical thing. Just make up some silly exercise, challenge yourself to do it, and see how far you get, you know. And if you keep doing that, your programming will steadily improve. Okay, so we'll leave it there for this video. Until next time, happy coding. Hello, this is John from caveofprogramming.com, and this is a tutorial on for loops, continuing my course on JavaScript and Node.js for beginners. So a for loop is probably the most common type of loop used in programming in general. Many of the constructs that we've seen, and generally most or all of the ideas that we've seen really, are found in a variety of programming languages with small differences between them. And a for loop is one of those things that's ubiquitous in a wide range of programming languages. And a for loop takes all the elements that you need to create a loop and basically puts them into a single construct. So if we think how we might write a while loop, so there are lots of ways to write while loops, but one common way would be to create a counter, set it equal to 0, and say while counter is less than 5 or whatever, and within the loop you have to increment counter. And we've seen this already, so if I do console.log and just output counter there, then let's run this, and for.js, then we get output 0.js, then we get output 0, 1, 2, 3, 4. Let's just bring this up a little bit. Okay. So if you look at what elements are here, now they don't all have to be present. None of them have to be present actually to create a while loop. If you were to write while, like while true, that would be an infinite loop, and then you could have some way of breaking it inside the loop. So one way is to use the break keyword. I could write, let's maybe take a quick look at that. So I could write while true, and I'll still increment the counter, but here I'll say if counter is greater than or equal to 5, break. So the break keyword breaks a loop. Let's just take a look. Let's just run this. And we get 0, 1, 2, 3, 4. So 5 iterations in total. Worth trying that out for yourself. And the point here that I'm making is that none of these loop elements are essential. Nevertheless, the most common way to write a while loop might be something similar to this. And you don't even have to say while counter is less than 5. You could say, set the counter to 10 and say while counter is greater than 0, and then decrement the counter with minus here. So there are lots of possibilities, but the important point is that there are 3 distinct parts to this, 3 distinct working parts. We've got a variable that we've created, which we've initialized in this case to 0. We've got a condition somewhere, typically here, that determines when the loop stops. And we also increment the counter, or we could decrement it depending on exactly how we're doing this loop. Now, a for loop brings all those 3 different parts together, and it looks like this. So an infinite for loop would look like this. So we write for, and again we have round brackets and we have curly brackets. So this is the same as a while loop, except we've got the for keyword. And within these 2 brackets, we need 2 semicolons like this, which looks weird, but you'll see why shortly. If I just write console.log in there, let's output hello. This is an infinite loop. So if I run this, it just goes on forever till I do Control C and stop it. But these 2 semicolons divide this area up into 3 sections, where we can put the 3 elements that we need of our loop. So the first thing that we need is a loop counter. And by the way, it's really common to use really short variable names for loop counters, especially in this situation. And it's actually particularly common to use I or if you've got another one, you need another one, maybe J, maybe K. So in general, we avoid short cryptic variable names, but when you use I in a loop, everyone understands what it means. So I'm going to write let I equals 0 here. Now this first section here will actually run before the loop starts. So that gives us an opportunity to declare and initialize a variable. This second section here, that's where we put the loop condition. So this will be checked every time one iteration of the loop executes. And as soon as the condition is no longer true, the loop stops. So let's write I less than 5. And then this third section here, this is going to get run every time the loop iterates. So after every iteration, this section will get run. Let's put I++. So if you think how this is going to work now, before the loop starts, we declare this variable I and we initialize it to 0. And every time the loop goes round, we are going to increment this variable I, increase the value of it by 1, and then we're going to check. We're going to see, is it still less than 5? If it is, do another iteration of the loop. If it isn't, stop the loop. So let's actually output the value of I here as well and run this. I'll just zoom out. And we can see we've got hello, 0, 1, 2, 3, and 4. So 5 iterations of the loop, because we keep going as long as I is less than 5, and we're starting I at 0, so 0, 1, 2, 3, 4. If you're new to this, the thing is just to practice this. Copy it from the video here or from my GitHub repository, where you can find that at github.com/caveofprogramming, and then just go to the repository for Node.js and JavaScript. And a really good thing to do is just to try it a few times and then try to write it without referring to any code. So don't see if you can write it from memory, in other words, and then practice. Just make sure that you can write a for loop that executes any particular number of times that you want, like 3 times, 2 times, 10 times, whatever. So try it out. And once you can do that, you've basically got the hang of it. So it looks a little bit complicated at first to a complete beginner, but it's just a little bit of stuff to remember. It's not absolutely not obligatory to put these things in these different sections here. The point of them is just that you have a section that runs before the loop starts. You have a condition that's checked before every iteration of the loop, and you have a thing that runs before every iteration of the loop, except for the first one. Well, actually, I suppose it's better to say this runs after every iteration of the loop, and this condition is checked before the loop executes. So you can put what you like in these 3 sections, and sometimes programmers get a bit creative with them, but that can get very unclear. So that the clearest thing to do is to do stuff like this, and if you've got other code, put it somewhere else. But nevertheless, it isn't uncommon to see other stuff in here as well. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at arrays in JavaScript and Node.js, continuing my course on Node.js and JavaScript for complete beginners. So in the last video, we took a look at for loops, and now we're going to look at arrays. So let's create a new file here in Visual Studio Code, and I'll call it arrays.js. And as usual, I'm going to write use strict at the top. So an array is a list of items. You can think of it like a numbered list of items. So let's create a variable. I'm going to call this days, and I'm going to set it equal to. And now we've seen variables that are of the type text. So I could write, days equals hello or whatever. And we've seen numerical variables like 7.3. But I can actually set a single variable equal to a whole list of things. And the way we do that is, well, there are various ways to do this in JavaScript. But again, here I'm going to concentrate in this first part of the course on stuff that is similar to what you get in other programming languages and that is also very common in JavaScript, just concentrating on the simplest ways of doing things and fundamental building blocks. So we write 2 square brackets here and then the usual semicolon. And in these 2 square brackets, I can put a list of things. Now, it's usual to put a list of things that are all the same type, although you don't have to. So here I'm going to write days of the week. Let's have Sunday, Monday, Tuesday, and that's enough, I think. So this is like, it's like a shopping list of, well, days in this case, which is a bit weird, but each of these items is numbered starting at 0. And the fact that that things in an array are numbered starting at 0 does tend to confuse beginners, but you just have to sort of get used to it. So to actually access we call these things elements. We call the items in an array elements of the array. And to actually access them, we do it like this. Let's write console.log and access an element of this array. So the first one would be sort of variable name and then square brackets and then a number like that. So this is item 0 in the array. So here we use square brackets to actually initialize a variable. Here we're using square brackets to actually create an array. And here, now that we've got the variable, we're using those same square brackets with just an integer inside to access elements of the array. And this is sometimes called dereferencing the array. So if we run this program, then let's run node arrays.js. We get Sunday, the first item in the array. We could also have, for example, set a variable equal to this. Let's try that with the second element at index 1. So let's write let day equal days 1 and then console.log day. So because we start numbering at 0, item number 1 in the array is Monday. So we've got 0, 1 and 2. And here we're dereferencing the array, getting a value out of it and getting an element from the array, and we're using it to initialize this variable day and then outputting it. Let's try that. Just going to clear my console. And there we've got Monday. Let's have, well, what's that? Didn't want that there. Okay. Let's try the final element. So the final element is, of course, at index 2. And that is Tuesday. You can have arrays that are absolutely massive. So there we go, Tuesday. We've got 3 elements here, but and you know, if you're having to initialize arrays by hand, sort of hard coding in literal values like this, then you're not going to have many values because it's going to get boring to type them. But you could, for example, initialize an array from values in a file or from values that you've created somehow, and arrays can then potentially have, you know, even millions, tens of millions or whatever entries in them. So you can put a lot of stuff in an array. We could have an array of numbers, for example. So let's write what should we call this? I don't really know. Heights equal. Imagine these are heights of a bunch of people. So we have the square brackets, and then we have how high they're going to be, 1.7 maybe meters, 1. 6.5, 1.5, 1.9. And we can do the same thing with that, just, like console.log. So for example, this would be at index 2 in the array. So that's index 0, 1, 2, 3. So let's output it, heights 2. JavaScript, unlike many more strict programming languages, doesn't always force you to put that semicolon at the end of a statement, but it is a good idea to put it in. Okay, let's try running this. And we get 1.5 down there. We can mix things of different types in JavaScript arrays. So let's maybe first, though, look at how we would iterate through an array. So one thing to say is that we can get the length of an array. So we can do that like this. Let's get the length of this heights array. Console.log heights.length. So we use the variable name of the array and then .length, and that tells us how many items are in the array. So if we run this, we see there are 4 items. Let's write here items in heights array. I tend to revert to using double quotes because they're probably more common in programming languages, so I'm used to typing them, but I do sort of prefer single quotes for JavaScript personally. I don't know, I just think it looks nicer. Anyway, let's try this. So items in heights array 4. So we've got 4 items in the heights array, but notice the last item would be at index 3, so 1 less than the length of the array. And that's because we start numbering at 0. And this can be confusing. Sometimes we call it the off by 1 problem, or related problems. We call them the off by 1 problem. You have to remember that the last element of the array is at index length -1. So we can actually iterate through the whole array and output every item in it with a for loop. And if you've been following this course from the start and you're a relative beginner, I would recommend now trying to do that yourself. See if you can work out how to do it. Can you use a for loop to output every item in an array like this one? And I'm going to show you how to do it. So if you want to have a go at that, pause the video and try it. So let's write for. I can use let I equal 0. I less than heights.length, I++. And then we can use I to access all the items in the array. So I can write console.log heights square brackets I. Let's maybe put some text here so that the output isn't too confusing. Item in heights array. I could even put item, let's write item I in heights array. Let's try that and see what it looks. So what it looks like. So we get this. So this stuff here. And we've output successfully the entire array. Now, in JavaScript, we can actually put things of different types in arrays. So I could write here hello like that, and if I now try to output that array, it still works. But it has to be said that in general in programming, if you have an array like this, generally you're going to put things of the same type in it, and generally you're going to write code that treats the elements in the array all in the same kind of a way. So you want them to be all the same kind of a thing. All right, we'll leave it there for this video. And the thing to do as always, if you're confused by this, or even if you're not, if you're not used to working with arrays and using for loops and things, you just practice this. Try it out for yourself. Try to get to the point where you can just write it out from memory. I don't think it's helpful to take notes. I do think it's helpful to type this stuff out even multiple times until you can do it from memory. And don't forget, you can also find my GitHub repository at github.com/caveofprogramming, and then go to the repository for this course if you want to browse the source code online. Okay, we'll leave it there for now. Until next time, happy coding. Hello, this is John from caveofprogramming.com, and this video is on two-dimensional arrays, continuing my course on Node.js and JavaScript for beginners. So a two-dimensional array is like a table. We've already seen one-dimensional arrays. That's like a list of things, but we can create multi-dimensional arrays, and of those, 2D arrays are by far the most common. So we write here, use strict as usual. And let's create a 2D array. A 2D array is basically a normal array, a one-dimensional array like the one we've already seen. Just going to clear this console. Except that in a 2D array, each of the elements in the array are themselves arrays. So I'll create a variable, let's call it animal table, and I'm going to set it equal to some animals. It's going to be a 2D array of animals. So to initialize it with values here, I'm going to create an array, but the thing is now, let's create some blank space here. The elements that I'm going to put in this array are themselves going to be arrays. So this is very much like a table. So for the first row, we have square brackets to denote another array, and in there I'm going to put dog and cat. And then let's have another row in here. Let's have some exotic animals on the second row. So let's have exotic, I mean, for someone like me who comes from England. So giraffe, elephant, and rhino maybe. So what is this? It's like a table of animals, and we call it a two-dimensional array, and you'll see why shortly. So how do we access elements in this two-dimensional array or table? Well, we need two subscripts to refer to each element, and that's why it's called a two-dimensional array. Dimensions just refers to basically the number of indexes that you need to specify the position of an item in an array. So let's do console.log. Now, if I write animal table and we use one index, we're going to be referring to elements. So the elements in this outer array here are themselves arrays. This is an array, it's element 0. Element 1 here, that's an array as well. So if I output element 0 only, let's run it, we get dog and cat. And element 1 would be giraffe, element rhino. But because, so this value is an array, we can use another index to get particular items out of this array. So if we stick with maybe element 1, that's this thing here. Supposing we want elephant. Well, within this sub-array, this is element 0, this is element 1, this is element 2. Let's output element 1. So let's write 1 again here. And then we've got elephant. Elephant. If we try 2 within that second array, we've got rhino. Mentioned in my video on 1D arrays is that you can set elements in the array after you've created it. In fact, it's common to do that. We'll be looking at more of that later on. But for example, supposing I want to change this rhino element to some other animal. I can do it like this. So we have animal table, and we want to go to that's row 0, that's row 1. So we want row 1. So we put 1 in square brackets, and then within row 1, we want element 0, 1, 2. So we put 2 in square brackets, and we can set that with an equal sign with the assignment operator to something else. So we could put in here, let's say, capybara. Hopefully I'm pronouncing that right. One of those giant friendly rat-like creatures. Now let's do console.log animal table 1 and 2. So row 1, column 2, basically. And now we can see that we've changed Rhino to capybara. So we declared a variable and we set it equal to an array. So we've initialized the variable with a 2D array, and we output this value here, which was Rhino, at row 1, column 2. Or in other words, it's the it's the element 1 within this outer array. So that's element 0, element 1. And it's the second, it's element at index 2 within this. So 0, 1, 2, which is Rhino. We output that and we get Rhino. Then, remember, the interpreter is working downwards through our program, the Node interpreter. So then we change it to capybara, and we output the value of that, and we get capybara. So you can do this as well with 1D arrays. You can change the values within them. How would we actually output the whole of a two-dimensional array? Well, that's a little bit complicated, at least if you're a beginner. So I think we'll look at that in the next video. But the thing to do now is practice creating 2D arrays and accessing elements within them. So don't forget, you can also get the elements out and store them in variables. So we could write, for example, here, let animal equal like this, just storing the value in a variable. And then if we want to, we could output console.log animal. So that does the same thing as before. So if you're a beginner, definitely you want to practice this. Practice creating two-dimensional arrays, so you can have as many rows as you like, and within each row you can have as many columns as you like. Some languages would force you to have the same number of elements in each row, but in JavaScript you can create what we call jagged two-dimensional arrays, where the different rows have different lengths. It's not a problem. So you want to practice that with different numbers of rows and columns, and check that you can get the elements out, you can access them or dereference them, and check that you can set elements correctly. And if you practice that for a little bit, it will start to make sense to you. And then I think in the next video we'll look at how you'd actually write loops that could output the whole content of a two-dimensional array, and we'll look at nested loops. Hello, this is John from caveofprogramming.com. In this video we're going to take a look at nested loops, continuing my series on Node.js and JavaScript for complete beginners. So a nested loop is a loop within a loop, and we can use a nested loop to visit each element in a 2D array, one after the other. Let's start with use strict as usual. And I'm going to copy the 2D array that I created in the last video. So I'm going to copy this animal table. So I've got let animal table equal, and I've set this variable equal to a two-dimensional array. So an array where each element is itself an array. And the challenge that we're going to do is, can we visit each of these items in turn, either setting them or outputting them with console.log. So how would we use a for loop to access these two inner arrays? So the two elements in this outer array here. Well, we could do it like this. For let I equal 0, I less than animal table dot length. So the length of it is 2, and I plus plus. And then we can just output console.log animal table and I. So if we run this code, we are visiting the two elements of this sort of outer array. That's element 0 and element 1. Element at index 0, element at index 1, and we're outputting them here. But each of those elements is itself an array. Let's maybe get each element in a variable. So I'm going to say let row equal animal table I, like this. Now I'm this variable row I'm setting first to that, and then when the loop goes around again, it gets set to this. So row is an array, and we can actually iterate over row using another loop. So I can write for let. Now we can't use the name I again here. The scope of this I variable, in other words, the area where it exists, is basically from here to here. So anywhere within there, we can't declare another variable called I. We could do afterwards, but within here we can't. So let's give this another name like j. I'm going to set j equal to 0. We're going to keep looping while j is less than row.length. And we're going to say j++. And then here we can write console.log. Let's output I and j so we can see what they are. And then I'm going to write row j. Take a look. So now we've got all the elements within this 2D array, dog, cat, giraffe, element, rhino. And you can see that the values of I and j are taking, well, all the values that we need them to. So we've got row 0, column 0 is dog, row 0, column 1 is cat, row 1, column 0 is giraffe, row 1, column 1 elephant, and row 1, so this one, column 2, which is that rhino, is rhino. We could also set the values in the array if we wanted, like this. So if I had another one of these, I could set each element in turn. And JavaScript is weakly typed, so we could even set them to numbers. You know, we could do what we want with them, really. We could say, for example, let's say row j equals I times j. See what that does. So we had strings in this 2D array. We're changing them all to numbers, where each number is equal to the row index times the column index. And then we get this sort of strange looking table here. So the point that I want to make there is really just that we can change the elements in the array via this mechanism as well as accessing them. Let's set them all to hello. And then they're all hello. But anyway, let's comment that out. So if you're a complete beginner, especially, or any sort of beginner, you need to practice this. So ideally try to get to the point where you can define, let's just move that down a bit actually, move it out of the way, there we go, with Alt or Option and down arrow. So you want to get to the point ideally where you can write this out from memory, not this exact code, but so first practice this, type it out, get it working, and then see if you can, without referring to other code, after a bit of practice, because at first you will probably need to refer to this code or other code examples, see if you can eventually get to a point where you can declare a 2D array and iterate through it using a nested loop. Incidentally, we could also write, here we could write animal table I j that works as well. I'm going to just copy that. That works as well. I'm going to just copy that and then just undo. I'm going to just copy that and then just undo. Because I wanted to show you this way first, because I think it's sort of simpler and it makes it clearer what's going on. I'll put this in a comment, and you can find this on github.com/caveofprogramming and my Node.js public repository if you want to browse the code there. So ideally get to the point where you can do it from memory. If you get bored and get sick of it, just move on to something else. Eventually, with practice, you'll be able to do this sort of thing, and it'll seem clear to you. It just takes some practice. I don't think it's very helpful to make notes. You just need to practice it, type it, get used to typing this sort of thing, really. And in fact, after you've typed things a few times, I find it's a lot easier to understand them than to do that the other way around. In other words, it's a lot easier to type stuff and then understand it than it is to understand stuff and then type. But typing stuff out and getting it working is vital to the process of learning with programming, absolutely vital. So worth trying this out. I'll give you an exercise with this, I think, probably in the next video, possibly. But for now, this is just enough in itself. So do try this out and see how you get on. Until next time, happy coding. Hello, this is John from caveofprogramming.com. We're continuing my free course here on Node.js and JavaScript for beginners. And in this video, we're going to look at adding to arrays. So far we've seen how to create arrays, including two-dimensional arrays, but we've initialized them when we declare the variable. We've been declaring them and initializing them with data at the same time. But what we can also do is we can add data to existing arrays, or we can even just declare an empty array and then add data to that. So first of all, let's take a look at what we would do for one-dimensional arrays, in other words, lists, because that's simpler than two-dimensional arrays. So let's declare an empty array. Let's say let fruits equal, and I'll use square brackets here to indicate just an empty array. So one way that you can add items to an array is just to use an index to set items, and the index that you use is the first index that's off the end of the array. So if I were to refer to fruits 0 here, because this has no items in it, fruit 0, which would normally be the first item, doesn't exist. It's off the end of the array already, but I can actually set that item to expand the array. So if I write fruits 0 equals orange, that will actually expand the array and add one item to it. Let's do console.log fruits 0 to check that it works. And this is well supported by all browsers, and as far as I know, all major browsers, and has been for a long time. So here I'm going to run my programs, check that I'm in the right place. Yep. So let's do node and adding to arrays.js, and we can see we've got orange in that array. So let's do another one. What's the first item? What's the index of the first item that would now be off the end of the array now? That would now be 1. So we've got an array here with one item in it. So the maximum index that we can use to access items is 0. So if I pick the next index, it's just off the end of the array, 1. I can set that to expand the array. Let's write fruits 1 equals apple. And we could also output the length of the array, console.log fruits.length. And if we try this, then we find we've got an array with 2 items in it. We're displaying only the first one. Let's display the second as well. The second item, which is at index 1. There we go, we've got orange and apple. Now, this can seem counterintuitive if you've been programming in other languages, because many programming languages would not let you do this. JavaScript is in many ways unusually flexible. For example, if you did this in a C program or a Java program, it would cause problems. You can't access or set elements of an array usually that are off the end of the array, but JavaScript lets you do it. However, there is another way of doing this that is more similar to how you would usually do this in probably most other programming languages, and that's to use a method called push. So a method is a subroutine. It's a kind of function, it's a collection of code that is associated with an object, and an array here is what we call an object in JavaScript. So you don't really need to know that yet. We're going to cover that later. But what you need to know is just how you actually do this. So let's write fruits, and we use the method called push. So push adds items to the end of an array. Let's do push and banana. And then I'm going to actually move this code up so we can get the new length of the array. And let's also output this new item, which is now going to be at index 2. So if we take a look at this, then we see we've now got banana in the array. Why is it called push? Well, we're kind of thinking of an array here as it's kind of a bit like a stack. A stack data structure is a data structure where the first item that we remove is the last one we added. So if you think of like a stack of cards, a deck of cards, you can put a card on the top and you can take it off again. In computer programming, those kinds of data structures are called stacks. Now, an array is not a stack because we can read items from anywhere within the array. But this terminology, push, is used with stacks, and it indicates basically pushing something onto the top of a stack. In this case, we've got an array. If you think of it like a deck of cards, we're like putting a card on top of the cards, like pushing a card on top of the cards. It's a bit like that. I don't know if that information really helps, but we talk about pushing things onto the end of the array. And that terminology, I think, really comes from stack data structures. Okay, so we can iterate through our array as well, of course. We could do that in various ways. So let's maybe just use a for loop, a conventional for loop, which is, we've already seen that in the course. So let's do for let I equals 0, I less than fruits.length, I++, and we're going to see other ways of iterating through arrays later on in the course, and we'll access fruits I, because this is not necessarily the most convenient way to do this. Let's also output a blank line to kind of create some separation in our output. So if we look at the output now, here we can see we're iterating through the array. And you want to become really fluent with creating arrays, adding items to them, and iterating through them with a for loop. It's something you can just learn through practice. So how would we deal with a two-dimensional array? Well, with a two-dimensional array, the elements are themselves arrays. So let's create a two-dimensional array. Now we need kind of a table of something. So let's maybe write let animals equal, and again I'll set it equal to an empty array. Now there are various subtleties around this and various things you can do, but for our purposes here, this will be good to get us started. So we could add to the end of animals, for example, by using push. And what do we want to add? We want to add arrays. So let's say animals.push, and let's add the first row of this table. Now the thing that we want to push is itself going to be an array. So to denote an array, we write square brackets like this, and in there we can add a list of animals. Let's write dog, cat, and mouse. And that will add items to our two-dimensional array. And we could iterate through it using the technique that we saw in a previous tutorial. Or for now, I could just iterate through the outer array. Let's maybe put a blank line, again, console.log, and then do for let I equal 0, I less than animals.length now, I++. And we'll iterate through this array and output the elements in it, just as we did up here. And notice this I, the scope of it, in other words, the region where it exists, is just here. Outside of that, it doesn't exist. And that's why we can create a new I here. So I'm going to output animals I. And now we're outputting one row at a time. We've only got one row in it so far. So if I run this program, then we can see we've got an array of animals coming out, because the elements in this animals array are themselves arrays. And we can of course add more to it. So let's have another row in the table, and this time I'll put animals that I'm not familiar with, because we don't really have them in England, like tiger. Well, I am familiar with them. We just don't have them roaming about. Okay, lion and elephant. Kind of be nice if there were elephants in England. Probably a bit destructive, but anyway. Okay, so let's run this, and we can see down here, if you can see this, we've got 2 rows now. The second row is my sort of tropical type, or animals that we don't have in England. Okay, so that's it for this video. I'm going to give you an exercise in the next video, which you can do to kind of improve your fluency with this if you want. The main thing to do though is just practice it, and practice typing it out. Probably if you're a complete beginner, inevitably you'll make mistakes, but that's the point of practice. You'll correct your mistakes, and eventually you'll stop making them so much. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com, continuing my free course on Node.js and JavaScript for complete beginners. In this video, we're going to take a look at control characters, and we're going to see how we can write stuff to the console without creating new lines, which is what happens when we use console.log. And I'm inserting this at this point in the course because in the next video, I want to give you an exercise that will bring together a fair bit of what we've seen so far in the course. But to complete that exercise, you're going to need a bit more information. So let's take a look at it. First of all, I'm going to start all my scripts as usual with use strict. Now, if I write console.log here and output, for example, hello, what does this actually do? It actually outputs hello, and then afterwards it creates a new line character. So if we run this, let's run node control characters.js, which is my file. Try again. I hit the wrong button there. Now I've brought back the same command that was wrong. What I want is this. Okay, so if you look at what's happening here, we're outputting the text hello, and then you see that the prompt of my terminal appears again on the next line. And that's because console.log actually outputs what we call a new line character after any text that it outputs, meaning the next stuff you output is going to appear on the next line. We can maybe see that more clearly if we output 2 of them, and then if I run this script, you can see they're coming out on separate lines, and that's because we write hello, and then there's an invisible non-printing new line character after hello, and that causes the next hello to come out on the next line, and that has a new line character after it as well, and that means that my prompt character reappears on the next line after that. So these new line characters, they don't print, they're non-printing characters, they don't display a symbol to you, but they cause the next stuff you output to appear on the next line. And we can actually output those explicitly ourselves. Let's take a look. So I'll maybe comment this out with a multi-line comment, which is /* and then */. So that's a multi-line comment, and it means that this is interpreted just as a comment and not as stuff to actually execute. So let's write console.log, and we'll have a string. Let's write hi, and then I'm going to put \n hi again, like this. So \n is a non-printing character. It gets translated to a new line character. We have to have a backslash. This is called a backslash, whereas this would be called a /, and it's important that we have a backslash here. So this means output hi, then create a new line character. In other words, go to the next line, and then output hi again. And then console.log automatically outputs a new line anyway after the stuff it's printed. So there'll be another new line after this second hi. Let's try this. And we get hi on 2 different lines. We can also use \t. By the way, I don't have a semicolon here. JavaScript is designed to be pretty flexible in many ways. It often lets you get away without putting semicolons at the ends of lines, but you should put them in. It's good practice, I would say. In other words, it's best practice. It's what you should really do, because sometimes your code won't work without these new lines. Let's try something else. So this time I'm going to write, let's write hello, and this time I'll separate them with a tab character. Let's run this. So a tab character is like a sort of long space, basically. And we've got a sort of gap between these two hellos. And that's been created by this non-printing tab character, which we can create by using \t within a string. And a good thing about tabs is that they help you line things up. They sort of move things to the next tab position, or that's often what they do. Other times they're basically equivalent to typically 4 spaces or sometimes 2 spaces or whatever. So if I output console.log and we have cat/t, dog/t, mouse, and then on the next line we have maybe apple and orange and banana, then we can see our output is lined up. And as long as the strings aren't too long, typically you'll get lined up output. There's no real guarantee about it, but in this case it's worked. So tabs are quite good often for lining things up like this. Now, what if we want to output some text and we don't want a new line after it? Because console.log will always add a new line after we've finished outputting our text, whether it contains new lines or whatever itself or not. So even just console.log by itself will create a new line. So let's write console.log with empty brackets. And you can see here that after the last output and before my prompt is a blank line now. And that's just been created by this console.log. But sometimes we don't want that. So if we don't want it, we can use process. Let's press S, because otherwise I think my autocomplete is going to unhelpfully mess this up. This is Visual Studio Code I'm using here. So if you write process.standardout.write, and I write, let's say, let's write lion. And then let's write something else with process.standardout.write, like tiger. And you'll be able to see the difference. So this is again, is just a way of writing to the console, but the results here are a bit different to console.log. So if I run this now, we can see we've got lion and then tiger, and process.standardout.write does not create any new line after it. So the next output that I do will be coming out right after the last input. And sometimes that is very helpful. Console.log is really intended for debugging. So it was originally implemented in browsers, and typically you have development tools in your browser that you can activate somehow. And those contain a JavaScript console. And console.log, if you run JavaScript in a browser, which we'll look at later in this course, will output stuff to the developer console to help you debug JavaScript that's running in browsers. But here we're just using it on a command line with the Node.js interpreter, and there it works similarly to how it does in a browser, and it outputs text and then a new line after it. Now process.standardout.write, you don't need to know what this is in order to use it. We're going to cover concepts that you need to know to understand this more later on. But briefly, so process and standard out are both objects. We call them objects. Process is actually I believe standard out is anyway, must be. Process is actually an implicit object. So it's an object we say that's available to us when we write Node.js programs. And again, you don't need to know what that is, but we call it an object basically. Write is a method. In other words, it's a function or subroutine, a collection of statements that is attached to an object, in this case the standard out object. And this standard out object lets us write to what we call the standard output stream. So we've got standard out and standard in. And standard out typically kind of represents a console. So we can call standard out it's a kind of stream. It's like an output stream. So rather than a stream of water, let's say, it's a stream of data, and we can write things to it. We can write data to it, and then it will usually appear on the console. So you don't need to know that to actually use it, though. That's just to begin to get you used to some sort of ideas and terminology that we'll look at later. So you can use control characters if, in strings that you're going to write with process.standardout as well. Like if I were to put, for example, /t or /n there, you'll see the results of it. Let's put /t after lion and /n after tiger. And if we actually output this, then we've got lion and then a tab character, and then after tiger there's a new line, so that my console prompt is reappearing on the next line now. If you want to output numbers with process.standardout.write, there's a bit of a twist. So let's try that. Let's have a variable, let's say. So let's say let value equal 7. So we've got I've declared a variable called value, and I've initialized it to the value 7. And I'll use process.standardout.write, and we'll output value. What does this do? Let's run it. In fact, it gives me a error trace or stack trace. So console.log, because it's intended for debugging, in many ways it's very flexible. It will output numbers, it will output all kinds of things. Process.standardout.write is in many ways less flexible. It won't output numbers, it will only output strings. So this error here, if we look at the top of it, actually says the chunk argument must be one of type string or buffer. It's not liking the fact that this is a number. But we can convert a variable that refers to a number, we can convert it to a string using the toString method. And that looks like this. If I write value, so still within these round brackets of write, if I write value.to.toString, and let's put empty round brackets in there, because this is actually a method itself, then that actually works. Let's try it. And now it works, and we've got 7 there. If I wanted to get this single line to have a new line after it, well, I could just use console.log, but you can concatenate strings together as well. So here I could write plus and I could have a string that only contains a new line, for example, and that will create a new line afterwards. Now you can see my prompt is now coming out on the line after that 7. Okay, so we're going to be using these ideas, or at least some of them, probably all of what we've seen here, in the exercise that I'll give you in the next video. So the thing to do if you are a beginner is practice this, try all of this stuff, try process.standardout.write, try writing numbers with it as well as strings, and try embedding control characters \t and \n within your strings and see what it does. Check that you get the idea of all this and you can use it to sort of arrange text on the screen, and then I'll give you an exercise in the next video. So until next time, happy coding. Hello, this is John from caveofprogramming.com, continuing my free course on Node.js and JavaScript for complete beginners. In the last video, we took a look at control characters, and we also saw how you can use process.standardout.write to write text without a new line appearing after it. In this video, I'm going to give you an exercise that's going to use this stuff, and it's also going to use a lot of what we've seen so far in the course. So, as always, I would say, if you're a beginner, don't feel that you've got to plan out programs in your head at the start necessarily. That can hold you back. So if you have a program you want to write, whether it's an exercise or it's just something you've thought of, have a go at it, see how far you can get with it. Can you write any bits of it? Can you write something that's similar to what you actually want? You know, just have a go, get in there, type stuff, see what it does, experiment. And I think that's a lot more profitable than just staring at a blank sort of page and thinking, how would I start and complete and finish this program? You know, just launch into it. So I'll give you an exercise. You may find it very easy, but then again, you may find it very hard. The important thing is just to try, or else if you don't do this, do some practice of your own, because you have to practice this stuff. You can't just watch videos. You've got to practice stuff to be able to use it. So bear in mind that when I give you this exercise, the thing to do is don't just look at a blank screen and be overwhelmed by it. Just have a go at it and see where you can get with it. See what bits you can do, you know. So I'll describe the exercise, and then you can pause the video if you want to try it, and then I'll actually show you how to do it. Okay, so as usual, I'm going to start my multiplication.js here, my script, with use strict. So this exercise here is to create a multiplication table. That's not quite all the exercise though. So what we want to do is we want to end up, let's clear the console here, it's annoying me. So we want to end up, let's use a multi-line string here, a multi-line comment. We want to end up printing, in other words, displaying on the console, a multiplication table that looks something like this. So we have the times 1 sort of multiplications. Let's write 1, 2, separating these by tabs, and we go all the way up to eventually 1 times 10. Then on the next line we'll have 2, 4, 6, 8, all the way up to 20. And then we'll have some more lines, and then finally the last line will be 10, 20, 30, 40, all the way up to 100. Ideally these should be lined up, but if they're not exactly lined up, then that's okay. So we want to print this, in other words, output it on the console. It's the 10 times multiplication table, all the way from 1 times 1 to 10 times 10. And the dots are sort of bits you've got to fill in. But there's a little twist here, because I'm going to suggest that you create a 2-dimensional array and fill all this data, all these numbers, into the 2-dimensional array. And then later in your program, after some blank lines, write some code that outputs the entire content of that 2-dimensional array. So the end result will be that you will print this 10 times 10 multiplication table. But you'll do it by first filling in a 2-dimensional array, and then later on in your program you will work through that array and output it all. Okay, and these are tab characters separating the numbers, and after each line we have a new line character so that each line comes out on a separate line. Alright, so if you want to have a go at that, pause the video now and try it, and don't forget, just try to do some bits you can. If you're overwhelmed by the whole thing, just simplify it. Can you even output these numbers? Never mind about the array, never mind the table. Can you output 1, 2, 3, 4 and so on? So start simple and build up and see where you can get with it. Alright, so pause the video now if you want to try that. Alright, so let's take a look at it. The first thing that we need is a two-dimensional array. And a two-dimensional array is a one-dimensional array where the elements are themselves arrays. So let's create a one-dimensional array. I'll just call it table. So let's say let table equal an empty square brackets to initialize it to an empty array. Now, if I wanted to just add one row to this table, I would create a loop like for let I equal 0, I less than 10, let's say, I plus plus. And then we could add values to that table. So I here will go from 0 to 9, which is not quite what we want, because even for the first row, we want 1 to 10, not 0 to 9, but it's a big step in the right direction. What if we wanted not just one row, but 10 rows? Well, then we could have a loop within our loop. So we could have let's call this j equals 0, j less than 10, j plus plus. Can we use that to fill a two-dimensional array with numbers? So could we even use it to create a multiplication table that goes from 0 times 0 to 9 times 9? Let's try that. So we want to add rows to our table. So within this outer loop, we've got to create rows. Every time we go around this loop, we need to create a row and add it to the table. So let's write we'll call it row equal an empty array, and then we can add values to this row in this inner loop. So row.push j. That would give us that would basically just loop around and create 10 rows, but we haven't added them to the table. So after we add some numbers to the row, let's do table.push and add the row to the table. So now we're adding 10 rows to our table where each row contains the numbers 0 to 9, which is a step in the right direction. Let's already see if we can display that. So we'll go down further in the program, and how would we display this? Well, we could display it with a nested loop again. So we need to, for each row, we need to work along the row and output the numbers. Let's try this. So let's have for int I equals 0, I less than 10. Actually, how big is this outer array? The length of it is table.length. Let's do that. And I plus plus. And then within that, that's not int, that should be let. I'm getting confused with C and Java. All right, so within that we can write for let j equal 0, j less than what? Well, we need to get a row out of the table. Let's do that. So how would we get a row from this table? How would we get the row, the ith row? We could write let row equal table I. And then the inner loop's got to iterate over this row. So we could write let j equal 0, j less than row.length and j plus plus. Then we can get values out of the row. So we could write let value equal row j. Let's display these values and see what we've got. I don't want to get each value on a new line, so let's use process dot, that's autocomplete being unhelpful, process esc dot standard out dot write, and we output value here. What does that give us? Let's have a look. Got to run the right file that would help. So node multiplication.js. We've got an error. Why is there an error? Well, it's because process.standardout.write will not write numbers, it will only write strings. So as we saw in the last video, here we have to write to string. Let's try that. Yeah, well, we've got a load of numbers, but for one thing, we've got one massive line. We need new lines in there. Where should we put the new lines? So every time after we output a row, which we're doing here, we want a new line character. So we could use console.log to do that. Let's write console.log and just empty brackets and see how that looks. It's a lot better, but well, the numbers are clearly not the right numbers, but they're halfway what we want, really. So can we separate the numbers by tabs? Well, after each write of a number, we want a tab character. So I could just add on a tab here with plus, or I could use another process.standardout.write. Let's try it. \t. What does that look like? Now the only problem is we're outputting the first row. Well, that's not the only problem, but we're outputting the first row over and over again. It also starts at 0, which we don't want. So we need to now we're outputting this two-dimensional array successfully. We need to take a look at the content of it, which is not quite right. So to get the multiplication table, well, all I need to do really is multiply I by j. So multiply the sort of column index by the row index, really. So if I write let's write I times j. How does that look? Okay, let's zoom out and go back to the console. I did something wrong here. Oh no, there we go. Right. I'll just clear this and then output it. So now it is a multiplication table. The problem is it goes from 0 times 0 to 9 times 9. We want it to go from 1 times 1 to 10 times 10. Really what we want to do here is, instead of I times j, we want to add 1 to I and add 1 to j. So we can do that if we're going to have to use brackets to stop this expression that we're going to write being translated in the wrong way. But let's write I plus 1 in brackets times j plus 1. So that means that we add 1 to I before we multiply it, and then we multiply it by j plus 1. So let's run this. And we've got what we want. We've got 1 times 1 all the way up to 10 times 10. Okay, so if you did try this exercise and you got this printing out and you used a two-dimensional array to store the numbers and then access them again afterwards, then you've successfully completed the exercise, whether you use the exact same techniques that I've used here or something slightly different. If you tried the exercise and you just couldn't get it to work, then don't feel bad. You know, if you did anything at all, that's really great. And I would say if you didn't get the exercise to work, try typing out this code and, you know, see that it actually works. You'll learn a lot just by typing it out, and try experimenting with it and check that you understand it if possible. Try to see what's going on. If you don't quite understand something, why something's there or whatever, try removing it or changing it and see if you can figure out exactly what's going on here. That's a really good thing to do. So it was a difficult exercise if you are a complete beginner. So don't feel bad if you couldn't get this working, but now you've seen how it is done, try it out for yourself and check that you can get this code working. Don't forget you can find all the code for this course on github.com/caveofprogramming, all one word, and then go to my Node.js repository. But there isn't value for learning purposes, there isn't value really in copying and pasting code. What you need to do is type it out yourself, even if it might seem boring. And if you find yourself getting too bored by typing, don't forget you can learn to touch type. You know, if you search on the internet, there are lots of free touch typing programs that teach you to type without looking at the keyboard, and that can massively speed up your typing. Probably only half of programmers do touch type. You don't have to, but it can speed up your learning by making you essentially less reluctant to type stuff. And it's a bit tricky to learn at first, but after a few weeks of forcing yourself to just touch type with emails or whatever you write, then you know you'll get the hang of it, and it will speed up your learning, I think, with coding quite a lot. But anyway, okay, so we'll leave it there for this video. Until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video we're going to look at functions, continuing my course on Node.js and JavaScript for beginners. So functions, for many people, are the point at which they start to feel that they're not quite sure what's going on with JavaScript. Many web designers, I think, use a bit of JavaScript and they're okay with it to a point, but when it gets to functions, well, maybe they're still okay, but then they gradually start to lose the thread of what's going on. So if you are a web designer, welcome to the course. And if you're not, that's great too. So let's start with use strict here. What actually is a function? Well, in mathematics, there's an idea of a function which is fairly strict. And a function in mathematics basically takes in some kind of number, not necessarily a number in the sort of traditional sense of it, but it takes in some kind of a number and it gives you back another number. So it's like a black box where you give your function a number, it may or may not do something with it, and then it gives you another number in return. So you can think of it like a mapping from one set of numbers to another. But anyway, in programming, functions are something a bit different, but similar. So a function is basically a collection of statements which you can then easily run. And functions can sort of accept data, as we're going to see, and they can give us data back. But in this video, let's just take a look at really basic usage of a really simple function. It's just a collection of statements. And there are actually quite a few different ways of defining a function in JavaScript. And here we're going to look at probably the simplest way of creating a function, and the way that's also most similar in a way to most other programming languages, I would say, sort of oldest way as well. So let's supposing we have some series of statements. So for simplicity, let's actually have a loop. Let's write for let I equals 0, I less than 3, I plus plus. Typical for loop. And in there I'll just write console.log. And let's write hello and I, just to get some output. So if I run this program now, let's run node functions.js, we get hello 1, 2, 3. Now this might be some really useful code which we might want to run at various times in our program. And what we can do is package it up into a function, and then we can run it when we want. So function syntax, to create a function, we can use the keyword function, and then we need to give it a name. Let's call this function greet, just a name that I've made up. And following that, so if you look at this, this is a bit like declaring a variable, except instead of let or var, we've got the keyword function, but then we've got a name like we would with a variable. But a key difference here is that we then have 2 round brackets like this, and then we've got 2 curly brackets, which, as with loops, is where we put the code that we want to run. So let's take this code and transfer it into the function. I'm just going to hold down the Option or Alt key and use the down arrow here to move it. And Visual Studio Code helpfully indents it for me. So I've taken this for loop and put it inside this function here. And we can then run that code whenever we want by typing the name of the function and again 2 round brackets. And I'll finish this statement with a semicolon, which I think is good practice. It's the best thing to do. Let's clear the console and run it. And you can see it does the same thing as before. So some things to say about this. For one thing, when we have curly brackets like this, I think I've mentioned this before, but we need to really make sure we do this. When we have curly brackets, the code inside them gets indented by 1 tab. Now, some people prefer using spaces, and programmers can get famously opinionated about this. So there's a really funny TV series called Silicon Valley, and in that there's a programmer who splits up with his girlfriend because he thinks you should use tabs to indent things, and she thinks you should use spaces. Probably funny only to a programmer, but programmers do get strong opinions about this. The most important thing though is consistency. If you're working in a team of programmers that indent stuff with 4 spaces, typically it will be 4, then you should do that. And if they use tabs, then you should use tabs. Fortunately though, I prefer tabs, and I hate typing out. I really don't like typing out 4 spaces, but fortunately you can always configure editors to turn tabs into spaces or spaces into tabs or whatever. Anyway, the important thing, the vital thing here is that between curly brackets, you've got to indent the code that you put in there. And I'm going to say by 1 tab because I like to use tabs. So within these 2 curly brackets, we've indented all of this code by a tab. And because we've got more curly brackets here for the for loop, this code gets indented by another tab. That's very, very important. And if you're using Visual Studio Code, you can actually, so on the Mac that I'm using here, if I hold down the Option key, press Shift, and then F, it formats the code automatically for me. So on Windows, I'm guessing that would be the Alt key, Shift, and F. It might pop up a dialog asking you to choose a formatter, but you should be able to do that. If you've installed some plugins for working with JavaScript, you should be able to get auto format working so that when you press Option Shift F or Alt Shift F, it formats your code automatically for you. I would strongly recommend trying to get that working. And you should always strive for good formatting when you actually write your code. But I think for beginners especially, auto format is very, very helpful. It gives you a check, enables you to make sure that you have indeed formatted your code reasonably. And well-formatted code is much easier to read than badly formatted code. So this isn't just a cosmetic thing. As far as the JavaScript interpreter is concerned, formatting is cosmetic. But as far as we're concerned, it's vital. It makes your programs maintainable and readable, or it's a vital part of making them maintainable and readable. Okay, anyway, let's get back to the main subject of this tutorial. So what have we actually done here? So we've created a function called greet, and this function greet is a collection of statements. In this case, it's just got a for loop in, and we can then run this function greet whenever we want. So here we're defining the function. We're saying what this function does, and here we're calling the function, or in other words, we're making it actually run. So this does not run any code. It simply defines a function containing this code. It doesn't actually run anything. This is what actually runs your function. So here we're calling the function, we're actually running it. If I don't put this in, let's comment it out, and I just run this program, it does nothing. Let's put it back again, and then it runs the function. Now the thing about this is we can call it whenever we want in our program, whenever we need it. Let's call it again here. There we go. Let's have another one. I'm running that function twice. You can imagine this is extremely useful. For one thing, it means that, you know, if you've got the same collection of statements that you want to run multiple times, you don't have to type them multiple times, and indeed you shouldn't. You know, if you're running the same thing multiple times, put it in a function and call the function multiple times. For another thing, it's a great tool for making your programs, just like making them more readable and making them more maintainable, sort of breaking them up into separate pieces that you can call when you need them. We're going to look at more advanced ways of arranging or structuring programs, but this is a great start. We could even call greet in a loop if we want, then effectively would have a loop within a loop. Let's just call it one more time. So hopefully you get the idea. So again, the thing as always is just to practice this. Type out this, get it working, and then try to be a bit creative with it. Try to define your own function, call it whatever you like, and put some statements in it. You don't have to have a loop. You can put what you like in a function as long as it's valid JavaScript, and try calling it. And don't forget, try to get auto format working. Use auto format constantly is my recommendation, but also try to format code nicely when you actually write it as well. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at function parameters, continuing my course on JavaScript and Node.js for beginners. So in the last video, we took a look at how to define a simple function. Now actually, JavaScript is very flexible. It lets you define functions in a variety of ways, and we can also put functions in structures called classes. And we can do functional programming where we're passing functions to functions, but we're going to look at that later on. Here we're just going to concentrate on some basic building blocks and getting some basic ideas straight. So let's create a new file here, and I'm going to call it parameters.js. We'll start with use strict, and we'll create a function. Let's create a function. I'll call it greet again, which is what I called it in the last video. So function names basically follow the same convention usually as variable names. So if you wanted to create a function called greet person, let's say you wanted to create a function called hello world. Usually you'd start it with a lowercase first letter most often, or it's the most common convention. And the second word of it will begin with an uppercase first letter, like this. I'm tempted to actually call it hello world, but anyway, no, let's call it greet. So as before, we have the keyword function, and we have a name that we made up for it. And then we have two round brackets, and we have two curly brackets. And in here we can put some statements, whatever we like, as long as it's valid JavaScript. Let's write console.log and hello. So this by itself doesn't do anything other than define a function. If I run this now, so node parameters.js, nothing comes out. We have to actually call the function somewhere, and we can call it wherever we like in our program here. So what we would normally do is this. So let's write greet to actually call the function. In other words, to actually make the function execute. So to make it run the code that it contains. And then if I write node parameters.js, it says hello. Let's try moving greet above here, above where we define the function. And it actually still works. So in some programming languages, you could only call the function after you've defined it, and that still looks kind of right to me. So if you think about the JavaScript interpreter sort of reading downwards, it's going to go down, the function gets defined, and then we can actually call it. But actually JavaScript typically is very flexible, so it allows us here to call the function before we've actually defined it, and it's able to go and get the function definition for you. But that's not true in all programming languages, so it's worth being aware of that. To me, it kind of feels more right, because I'm used to other programming languages to call the function after it's defined. Anyway, we're going to look at function parameters in this video. So in the last video, I said that the idea of functions comes from mathematics, and a function in mathematics is like a black box where you throw a number into the box, so to speak, and it processes the number and spits another number out. And in programming, we don't have to pass any data to functions, and we don't have to get any data out of it. So here we're not doing. The function is purely some statements that it executes, but we can nevertheless pass data to a function, and we can get data out of it again. Let's take a look at how to do that. So supposing we want to alter the behavior of this function so that it outputs a name, so it says like hello Bob or whatever. Between these two round brackets, we can write the name of a variable. So it's, although in effect here we're declaring a variable, but we don't use any kind of word like let or anything. We just write the name of the variable that we want to use. So let's supposing I want a variable called name. I just write name there. And this is something that I'm going to pass to the function when I call it. So the function is going to have this name, whatever's in there. We don't know, could be anything, could be a number, but hopefully it's something appropriate because we've called it name. And I'm going to output that with console.log. Let's write comma name. Now, this says that this function has a parameter called name. In other words, it can accept some data which is going to be placed in this name variable. To actually pass that data to the function, when we call it, in the round brackets after, where we actually call the function, we can pass in some data. Let's write Bob. And let's run this and see what it does. So I run it and it says, hello Bob. What's happening here? Well, a kind of analogy I like to make is that when we call the function, the two round brackets here are kind of like a chute. And what we're doing is we're throwing Bob, in this case, down the chute. We're throwing some data down the chute. The chute comes out here where we define the function, and this Bob ends up getting thrown into this variable here, and then we can use that variable here. So let's try it again with a different name. Let's write greet, and let's write Claire. Got to be got to use male and female names equally, but then there are also sort of names that are neither male or female. It's a minefield basically. But anyway, let's run this. Okay, so hello Bob and hello Claire. So we're using the same function, but we're changing how it works, because the first time it says hello Bob, the second time it says hello Claire. If you've ever used a synthesizer, like the musical instrument, it will have various things that you can change and control, and we call those parameters. So you change the parameter values on the synthesizer to change what sounds it makes. Functions are kind of the same, so we call this a parameter because it changes how the function works. This is a function parameter. And it is also a variable, and we're outputting the variable in our console.log. When we actually pass values to the function, we call them arguments. So we supply an argument to the function. Kind of strange lingo. Why it's argument? I guess that comes from mathematics as well. But you'll get used to it. So this is a function parameter, this name variable here, and here we're passing arguments to the function. We can actually also pass more than one. So supposing we wanted to pass in the name of a day. So we can have a list of parameters here. Let's write comma day. So I'm not using it at the moment. If I were to run it at the moment, so many programming languages would, if I try to run this now, so I've got a function that expects 2 arguments because it's got 2 parameters, and I'm running it each time with only 1 argument. Many programming languages would gag at that point. They would refuse to execute. They would say, no, this is wrong. But JavaScript happily executes it, does the same thing as before at the moment. JavaScript's extreme flexibility partly comes from just I suppose it being an interpreted sort of scripting type language. You know, it interpreted in the sense that when you run it, there's an actual program, Node in this particular case, that's actually interpreting the program and running it. And interpreted languages tend to be more flexible than compiled languages, where you take text and you turn it into a binary file, you compile it into a binary file. It's also weakly typed, so variables don't have types. It's not like we have one kind of variable that's an integer and one that's a piece of text and so on. You know, we have weak typing in JavaScript, so it's very flexible in the nature of it. And because it was originally designed to run in browsers, it doesn't make any strict demands on the programmer, and it lets you do things like this. But anyway, let's actually make use of this day variable. So let's say hello, comma name, comma full stop. It is, and then let's output the day. What happens if I run this? So now I've got this day parameter, but I'm only supplying 1 argument, just the name, each time I run the function. If I run this, it says it is undefined. So it lets me refer to day, but because I haven't actually given it a value, it just says undefined. But let's give it a value. So here I'm gonna, when I actually call the function, I need to supply, ideally, usually, most of the time, I'm going to be supplying a list of arguments that matches what we've got here. So let's write comma Tuesday. And here let's write comma Saturday. So if I run this, it says, hello Bob, it is Tuesday. Actually, this looks a bit ugly with because console.log puts a space here. Let's get rid of that full stop. That'll do. It's quite ugly actually. Maybe it looked better with a full stop in. It doesn't matter anyway. Hello Bob, it is Tuesday. Hello Claire, it is Saturday. So, you know, again, going back to my chute analogy, it's as if we've thrown the values Bob and Tuesday down the chute, and they end up getting stuffed into the corresponding parameters here, and we can make use of them here. We can also, of course, you might guess, we can pass variables instead of literal values. So let's say we have a variable, we can call it what we want. So we could call it, let's call it something other than day, like day of week equals Tuesday. We can pass day of week here instead of a literal hard-coded value. And this works as before. This can also be confusing to beginners because this variable doesn't have the same name as this variable, but it doesn't matter. The mechanism here is not trying to match names of variables. This is simply an argument, it's simply a value that gets passed to the function, thrown down the chute, so to speak, and it ends up being sort of received at the lower end of the chute here. So you're just simply taking the comma-separated list values and shoving them into the corresponding variables here. And of course you can also pass in numbers as well and other kinds of things. You can even pass in arrays. So we'll leave it there for this video. The thing to do as always is try this out for yourself and see if you can get creative with it, see if you can change it somehow. Try functions with 3 parameters once you think you've got the hang of it, and see how you get on. It is just a question of typing this out to understand it. I don't think it's good to spend a lot of time puzzling over it. The thing is to actually try it, get it working for yourself, and eventually your fingers will start remembering what to type, and this will become second nature to you. So until next time, happy coding. Hello, this is John from caveofprogramming.com. In this video, we're going to look at function return values, continuing my course on JavaScript and Node.js for complete beginners. So in the last video, we took a look at function parameters and passing arguments to functions. Now we're going to look at getting values out of functions with return values. Let's create a new file here and call it function, I'll just call it return.js actually for the moment. Okay, so start with useStrict. Supposing we want to create a function that lets us pass a value in and get a value out of it. So we've seen that functions are basically collections of statements which we can call, or in other words, cause to execute whenever we want. But we can also pass values to them, whether those are strings, arrays, whatever they are, numbers. And here we're going to look at getting values out of functions again. Let's create a function. I'm going to call this square. So if I just put for the moment console.log square, that defines a function, and to actually make the function run, we have to write square, and we can run it wherever we want here in our program. Now let's write node return.js to actually run the program, and it says square. So we can pass a value to it if we want. Let's create a function that allows us to pass in a single argument. I'm going to call this number, and we're going to pass in 7 as the argument. This is a parameter, remember? It's a function parameter, and we're going to pass 7 as an argument to the function. So 7 is going to end up in this parameter, and we can output it if we want. Let's write number there. This is like a variable, basically. And if I run this, we see it says square 7. Now whoa, what happened there? Let's just close that. I don't know what happened. So now we can also get values out of functions. Imagine that we want this function to square this number, in other words, multiply it by itself. We can do that like this. So let's get rid of this console.log and write return. So we need the return keyword here, and then we type what we're going to return. So actually let's calculate that first. Let's write let square equal number times number. So just squaring the number or multiplying it by itself, in other words. And then to actually return a value, we write the value that we want to return. This could be a string or a number or anything. And how do we actually get that? Well, when we call the function, it effectively kind of returns a variable. So we write let's call it value equal square 7. And then I'll output here value. And if we run that, it says 49, which is 7 times 7. We could write this more succinctly because we don't really need to have 2 statements here. We could just say return number times number. We could put here return number times number, and that would do the trick. But I've just written it out a bit more in a bit more of a complicated way here, just to kind of highlight the fact that we could have all sorts of calculations or all kinds of processing here. We could be doing all kinds of things. Who knows? Opening files, reading them. Who knows? But at some point in the function, well, at the end, in this case, we return some result of all our processing or calculations, and we can get it like this. So it's as if this function is sort of, to go back to my sort of chute analogy from the last video, sort of throwing 7 down a chute here, and it's emerging here, and it's getting put into this variable. And here we're kind of, don't really know how this fits with my analogy, but we're kind of returning or spitting out this value square. And when we actually call the function, when we actually execute it, we can say let value equals square, or let whatever we want equals square, and then we get the actual value that we've returned. So this can look confusing because it looks as though we're getting a variable and we're setting it equal to a function. That's not what is happening. What is happening here is that we are declaring a variable and setting it equal to the return value of a function, which happens to be, in this case, a number. So as always, the thing to do is type this out, practice it a bit yourself. Let's take another example here. I'll maybe get rid of this blank line. Let's go down and create another function. So supposing we want to create a function that returns a greeting. Let's write function, I'll call it greet. Do we want to pass it any arguments? Well, we could pass in, for example, a name. So let's just write name there. And again, this is just like value and like value and like number. This is just a variable name that I've made up. Could be anything within reason. And let's create a string here. Let's say let greeting. We wouldn't want to say here let greet equal. We don't want to get confused by using the function name for a variable. Give it a different name. Let's say let greeting equal, and we'll have a string hello, and let's add on to that name. This isn't ideal, as we'll see in a second, but we'll leave it for that for the minute. And then what shall we return from the function? Let's return this greeting. So I'm going to say here return greeting. Let's call this function. So I need to say, if I just write greet and then pass it a name like Neptune, perfectly reasonable name, and run this, it doesn't do anything apart from what I've already told it to do above. But I can now get the return value of the function. So this function, it's not outputting anything directly. It is only returning something. So when we talk about returning a value in programming, we mean a very specific thing. We don't mean that we're, for example, printing the value, like displaying it on the console. We mean we've got this return keyword, and we're actually returning a value from a function. So to access that value, I need a variable. Well, we could actually just write well, I didn't mean to do that. Let's do Control Z, undo. There we go. Right. We could actually do this, console.log, and this would actually use console.log to output the return value of this function. Let's try it. So it says hello Neptune. You can see that this is not ideal because hello is run together with Neptune. What we need to do is have a space after hello, so I can put that inside the quotes like that, and then it looks a lot better. So now we've got hello Neptune. But perhaps more often we would be storing the return value of a function in a variable and then using it further in our program. So let's write let, I'll call this greeting again. Let greeting equals greet, and we pass the argument Neptune. And let's write console.log greeting. And I run that and it outputs hello Neptune. Now in this case, the variable name happens to have the same name as what we were as the variable we were returning, but this is an entirely different variable to this one here. This variable, because it's declared inside these curly brackets, we can only access it actually within the curly brackets. This is an entirely different variable. So I couldn't write to lots of let greeting here. Let's set that equal to something. Let's see what that does. That gives us an error. It tells me that identifier greeting has already been declared. But here we say that the scope of this variable is restricted to this code block. It's not visible outside this code block. That's why I'm able to declare another variable with the name greeting here outside the code block, where this one is no longer visible. And there's no reason why this has to have the same name as this. There's no connection between them other than that this is being used to get the return value of this function. So I could call it something else. Let's write message. And we'll run this. And if any of this seems unclear to you, it will become clearer with practice. You do just need to practice this. It's like learning a musical instrument. Watching videos is not enough. You've got to actually do it yourself. The video is only a source of information to guide your practice. So it says hello Neptune. Okay, we'll leave it there for this video, I think. Maybe one last thing. By the way, if you've got a function that returns a value, you don't have to pass it any arguments. You could happily have a function that accepts no arguments and returns a value. Those are two separate things altogether. If you wanted to really quickly square a number, you don't actually need a function to do it. So you could just let's write console.log and math.pow, short for power, 7 to the power of 2, in other words 7 squared, and that would give us 49 again. Let's maybe pick a different number like 8. That should be 64. There we go. So if you look at this, this is actually calling a function and passing it 2 arguments. In this case, the function is part of what we call the math class. We haven't looked at classes yet. We'll be looking at them later on. But by looking at functions, we've taken a big step towards actually understanding what's going on here. Okay, so do try this out for yourself. Don't forget, you can find my Git repository by going to github.com/caveofprogramming. That's all one word, lowercase. And until next time, happy coding. Hello, in this video we're going to take a look at function expressions in JavaScript. So my name's John. I'm from the website, I'm the creator of the website caveofprogramming.com, and we're continuing here our course on Node.js and JavaScript for beginners. So I'm going to start with use strict as always. Sometimes I forget that, but really should try to remember it. And let's create a function in the most kind of basic way. So this is called a function definition, which we've already seen in this course. We write function, and let's create a function that maybe just says hello. So let's write function, I'll call it greet1, round brackets and curly brackets. So we can use numbers in function names and variable names. We just can't start them with a number. So this is a valid function name. I'm calling it greet1 because I'm going to have another 2 of these, and I don't want to have to think of completely different names every time. So I can have greet1, greet2, and greet3. And let's just write console.log, and we'll output hello1 here. How do I actually call this function? And when I say call the function This is programming lingo for make the function actually execute. And the answer is we just write greet1, the name of it, 2 round brackets, and we should put the semicolon in really. So if I run this now, it says hello 1. So we've already seen this, and this is called a function definition. Now, one thing to be aware of is that the Node.js interpreter or the JavaScript interpreter, whichever one you're using, it will normally start at the top basically and read downwards. So it's reading downwards, it sees your function definition, and eventually it comes, if you've got one, to a function call. So now we're calling this function, and by the time we do that, it's already seen the definition of the function, so it works. However, we can also, in this case, put the call to the function above the definition of the function. So we can call the function before we've defined it, as long as we do define it in our program. Let's try that. And it actually does work. And this is called function hoisting, which is a name that I discovered recently. I didn't know it was called that, but this does actually work with a function definition. But as we'll see, it doesn't work with the other styles of creating the function that we're going to see. So the second way to create a function is called a function expression. We write we need a variable here essentially, which will actually be a reference to the function rather than just a simple value. So let's call this greet2, and I'm going to set it equal to, and we need a keyword function. Then we have the round brackets as always, and the curly brackets as always. And in there I'm going to do console.log hello2. The name of the function, 2 round brackets, and ideally a semicolon, and ideally a semicolon. So if I run this, it says hello2, if you can see that. That works. However, function hoisting doesn't work with function expressions. It only works with function definitions. So if I try to call this function before I define it with a function expression, then I get a nasty looking error. And it says actually on the top line, it says cannot access greet2 before initialization. Let's put this back down here so that it actually works. Definition, and here we've got function, and here we've got function expression. We've got a function expression. Why is it called a function expression? Well, probably because in programming in general, an expression is something that evaluates to some value. For example, if I write 2 plus 2, that evaluates to the value 4. In this case, this expression evaluates to a function which we can assign to a variable, and then we can call the function. So this is a function expression, whereas this is a function definition. There's another way of writing a function expression that seems to be getting more and more common. I'm seeing it a lot in React code. React is a framework for creating basically web user interfaces. Let's take a look at that. So again, we have a variable to store a reference to the function. I'll call this greet3, and we set it equal to, and now instead of the function keyword, we have 2 round brackets, which again could accept a list of arguments. We could put a parameter list in there, and we have a equals sign and a sort of right angle bracket, sort of diamond bracket, and then we have the curly brackets. So let's put in there console.log function. We write again greet3, we write again greet3 and the round brackets. And if I run write again greet3 and the round brackets. And if I run this, it says hello 3. So there are these 3 different ways of defining a function. These are 3 important ways of defining a function. If you are a beginner, you will start to get lost just by looking at this. It's really important that you type all of this out and try it out for yourself. and try to give yourself an exercise. Now, or some exercises rather. In each case, we could supply function parameters. We could put function parameters in the round brackets. That's where they always go. And then we could pass those to the functions in our curly brackets here when we call the functions. We'll take a look at that in the next video. But if you think you understand how this might work, then do try it out. So you have to give yourself exercises of some kind. So for example, can you write a function that adds up all the numbers from 1 to 100 and then just prints them out, or else returns the value that it's calculated? Make up some silly exercises. They don't have to be anything really serious or useful, but make up exercises and try to practice all of these. Try adding up sequences of numbers, or squaring numbers like I've done here, or whatever springs to your mind, converting a temperature in Celsius to a temperature in Fahrenheit, converting a number of days to a number of months, whatever you like. Make up exercises and try to do them. You've got to practice this stuff to learn it. So in the next video, we'll take a look at how we would handle return values and parameters with these different ways of creating functions. But do practice this or you will start to get lost. So until next time, happy coding. Hello, in this video we're going to take a look at working with parameters and return values with different ways of defining functions. My name's John from the website caveofprogramming.com, and this is continuing my series on Node.js and JavaScript for complete beginners. So in the last video we took a look at function definitions and expressions, different ways of creating functions in JavaScript. If you've watched that video, hopefully you've practiced this a bit so that it's starting to seem familiar to you. In this video, we're going to do the same thing, but we're going to bring in parameters and return values. So let's maybe write functions that calculate factorials. So the factorial of a number is defined like this. Let's say we have, for example, 3 factorial. So we write it like this. So that's 3 factorial. What does it mean? Well, it's equal to 3 times 2 times 1. So you can guess that, for example, 5 factorial equals 5 times 4 times 3 times 2 times 1. Not that it makes any difference, it's multiplying by 1. This is a simple idea from mathematics. Can we write a function that calculates this? And you might want to pause the video and have a go at it and see if you can do it, because it's a good little exercise. Okay, so let's start by creating a function using a function definition. And the way we do that is we have function, we have a name for it, let's call it factorial1, because I'm going to have more of these. And we have round brackets and curly brackets. We want to pass a single argument to this function, and that's going to be the number that we calculate the factorial for, like 3 or 5 or whatever. So let's give that a name. We could call it, for example, value. So we're going to have to iterate over all the different values, sort of counting up to this actual value. Let's try it. It's actually easier to do this by writing a function that calls itself, but we won't look at that just yet. That's called recursion. Let's do it using a loop. So I'm going to have for let's call this maybe n, because it's like a number. N equals with 1, strictly speaking. We keep going while n is less than or equal to value, and then we increment n. So we start off setting the value of n to 1. We're going to keep looping until it's equal to the value that we pass in, and we'll also loop for that, but when it's more than the value, we'll stop. So when this condition's false and n is not less than or equal to the value, then we don't loop anymore, and then we increment n every time we go around the loop. So for a start, let's just do console.log n, and see what values we get for n when we call this function. And it's a really good thing to do to build up your programs bit by bit and check them along the way. Use console.log to check that they're actually working as you expect at each particular step. Don't write a load of code and then just run it, because that can get confusing. Write little bits and check that they're working. So let's call factorial. So we write the name of it, factorial 1, and we pass in some value like 3. So we expect this to print out 1, 2, 3. Let's see if it works. Node function expression parameters.js, and we get 1, 2, 3. So it seems expression parameters.js, and we get 1, 2, 3. So it seems like it's working okay. Let's try it for 5. We should have 1, 2, 3, 4, 5. Yeah, I just altered the wrong thing there. So I want to pass in 5 when I call the function. Unfortunately, I have trouble seeing over my microphone. Okay, 1, 2, 3, 4, 5, it's working. What we have to do is multiply all those values by each other. You know, it doesn't matter what order we do them in. So 3 times 2 times 1 is of course the same as 1 times 2 times 3. And we could start this at 2, it makes no difference, but just to make it look a bit simpler, I'll start it at 1. All right, so let's have a variable. Let's write let, and I'll call this factorial equal 1, maybe. And then what we have to do here is say, so we want to say factorial equal, factorial equals factorial times n dot log 120, which I think is correct. 20, which I think is correct. Let's try 4. 4 times is correct. Let's try 4. 4 times 3 times 2 times 1. So 4 times 3, what's that? It should be 24, I think. Let's run it. 24. Let's try it for 3. I want to return it rather than display it. So if we return it, let's say return display it. So if we return it, let's say return factorial. When we actually call the function, we can now get a return value. So let's say let result 1, I'll call it, equal factorial 1 of 3. So notice the function's called factorial 1, and I've got a variable here called factorial, so those are two different names. And let's do console.log result 1, and I'll try it for 4. Run it, we get 24. Now there is a bit of a twist here with factorial, which is that by definition factorial of 0 is supposed to be 1, and this isn't going to work with factorial 0, or is it? Let's try it. So if I say factorial 0, loop doesn't execute at all, so it does actually work. Otherwise I would have put an if in, so it does actually work. Otherwise I would have put an if in here to check if value is 0 at the start and then just returned 1, but this works anyway. All right, so let's look at doing this using function expressions. And if you've watched the last video and you think you can probably actually work out how to do it, then do go ahead and have a go, pause the video and try it. So let's write let factorial 2, and this time I'll use a function expression. So we write equals function, we have round brackets and curly brackets. In the round brackets we put our comma separated list of parameters. In this case we just have one parameter, and then we have to do these calculations. So normally you try not to duplicate code in a program, but here we're just doing the same thing 3 different ways just for demonstration purposes. So I just copy this code, it's going to be the same. And don't forget the indentation, and you should be able to run, I think it's Option Shift F or Alt Shift F to run the auto formatter. On my Mac it's Option Shift F. I'm guessing Windows Alt Shift F. Probably there's also a menu option here somewhere. But you want to make sure, look it up if you can't figure it out. But you want to make sure that you can run auto format in your works and use it a lot. I recommend it. But try to write well formatted code to start with. This is incredibly important. Okay, so now we've defined a function using a function expression, and we can write let result 2 equal factorial 2, and let's pass in 5. Should get 120, and then we can write console.log 5. I meant result 2. Okay. 20. We could also do 20. We could also do this like this. So I could write console and factorial. Let's call one of these functions like factorial 2, doesn't matter which one, and pass in 4 or something. So if I write this, so this is actually calling the function and then passing the result immediately to console.log, just without the intermediate variable that we have here. So this also works. If I run this, we're getting 24 down there. And finally, using the other form of what is essentially a function expression again, let's write let factorial 3. So I have to give it a different name. So I'm just going 1, 2, 3 at the end of the function name here. Equals, and this time we have round brackets, an arrow, and curly brackets. So basically we've got an arrow instead of the keyword function is the difference, and the order is slightly different, but it's pretty much the same as this one, and it is another kind of function expression. So if I just copy the content of this and paste it in, and let's call it, and this time I won't bother with the intermediate variable to get the value. I'll just write console.log factorial 3, and let's pass in 6, which should be 6 times 120. What is that? 720? Let's try it. So I did something wrong there. What did I do? What did I do wrong? Let's check. I forgot to add value as a parameter. So I want to be able to pass 6 to it. I've got to have a parameter here. Let's try that. So it's all working, and as I say, if you're a beginner, this is the first time you've seen this, you really do need to practice this. Give yourself, little challenges, add up lists of numbers or whatever. You can pass arrays to functions as well and return arrays. You just pass in the name of the array and you can, just return the array. That works perfectly well. But practice all of this. Make some challenges up for yourselves. Practice all 3 styles with parameters. You can have more than one parameter, of course. You can have a common separated list of parameters with various different names here. Try it all out and practice it, or you will get lost pretty quickly. So we're going to look at some other concepts in this course, and I want to get fairly soon to looking at what we can do with JavaScript in terms of actually things like running web servers and just sort of generally interacting with the world beyond the console on the computer, essentially. But we're probably going to have to look at some more stuff first. So the key to this is practice. Type it all out, try it all out, experiment with it a little bit, and then you're hopefully not going to get lost. But you will if you just watch the videos. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com. This is another video in our course on Node.js and JavaScript for beginners. And in this video, we're going to look at creating an HTTP server with Node.js and JavaScript. So far in the course, we've looked at basic building blocks of programs, essentially. We've looked at things like loops and if statements and functions. What we're going to do here is kind of jump ahead of ourselves a bit, because I know that you're not learning JavaScript just so that you can write command line programs that say hello and that sort of thing. So we're going to write a server program that's actually going to be able to respond to web browser requests. In other words, the output of our program is going to appear in a web browser instead of on the console. And to do that, we have to use various constructs that you haven't seen yet. But what I'm going to do is I'll try to explain a bit as I go along. You're not going to fully understand it though yet if you follow the course from the beginning and you don't have other experience. But as we progress through the course, you will gradually understand what we're actually doing here. So don't stress out about my explanations here. They're just to kind of begin to introduce you to some new ideas. But the point of this really is to write a little server app. So you're going to want to either while you're watching this video or afterwards, try this out for yourself, type it out. It's really important, and get it working and experiment with it a little bit. That's the only way that your fluency will increase. Okay, so I've created an empty file called server.js, and I'm going to write use strict at the top as usual. Now, JavaScript code for Node.js, it can be packaged up into things we call modules, and there are a bunch of standard modules that we can use in Node.js JavaScript. So if I go to the internet here and I search for something like Node.js HTTP, and that's what we're going to be using here. So there's a load of documentation here. And in fact, if you search for And in fact, if you search for something like meet server, then you can find example code for what we're going to do. But what I'm going to do is I'm going to write this in a little bit of a kind of more verbose way than what you would normally see, because it's going to be easier to explain it that way. So essentially, the word server in software development is used in at least two different ways. It's often used to mean an actual computer that is serving like web content of some sort, so serving web pages or whatever. So it's the actual computer that does that. But it's also used to mean a piece of software that can serve content of some kind. So in this case, we're talking about a piece of software. We're creating a little server program that can accept requests, we call them, from a browser and send back content that is displayed in the browser. What I'm going to write after use strict is I'm going to declare a variable, and I'm going to call it HTTP. HTTP is actually what we call a protocol. It's a specification for how data can be transferred. One way of transferring data between, let's say, a browser and a server program in this case. And the HTTP module, which is what we're using, is named after that protocol. So we're going to be using a standard built-in module in Node.js that can help us implement a server which works via the HTTP protocol, the HTTP specification for transferring data. That stands for Hypertext Transfer Protocol, if I remember correctly. So let's say, now this variable could be called anything, but I'm calling it HTTP because that's the name of the module that it's going to refer to. Let's write let HTTP equal require, which we haven't seen yet, but we'll look at later, and round brackets and a semicolon. And in there we're going to write, well, we're going to pass a string HTTP. So this basically enables us to get a reference to the HTTP module. Now we can use it to create a server. So I need another variable, which it makes sense to call server in this case, but again we could call it anything. Let's write let server equal HTTP.createServer. round brackets and a semicolon. So we're calling a function here of the HTTP module. Now we need to pass a function to create server, and so far in this course we've looked at passing strings and numbers to functions. We haven't looked at passing functions to functions, but sometimes you want to do that. So let's say that you implemented a button that you could click somehow on your screen. You want to pass code to that button which will be executed when the button is clicked. So in that situation you want to pass a function to a function. You want to pass a function containing code that you've written that will be executed when a button's clicked to the function, to the button, to some function attached to the button, so that the button can then call your code when it's clicked. And we're kind of doing a similar thing here. So we've got a server and we want to tell it what code to run when someone requests data from the server by going to the appropriate URL in a browser. So we have to create a function now that will be called when a request is made from a browser to our little server program here. So I'm going to use a function definition style here and write function. Let's call it request callback. We could call it anything. And that has to accept 2 arguments. So we need 2 parameters here. 2 arguments meaning 2 things are going to get passed to it, which have to then appear in our parameters. And I'm going to call the parameters, again, we can make up any name for them that we want, but we should call them something appropriate. So I'm going to call them request and response, using the response parameter here. So we pass a reference to this request callback function to create server, and then create server can actually call this function whenever we go to a URL in our browser. For the moment, let's just put console.log hello in there. Hello. Start the server up. So let's write server.listen round brackets and a semicolon. Again, we're calling a function here that's attached to this server object. Your computer has a bunch of different ports, and each one of them different ports, and each one of them can be used for transferring data between a browser and a server app like this. So we just need to pick a port that's free, and they're all numbered. So let's pick 8000 because that's usually free. Most of them are usually free, but I'll just arbitrarily pick 8000 here. And we could also output some text here like console.log and let's say listening ... In other words, we're going to, after we call this, we're going to carry on executing stuff in our program. After we call this, we're going to carry on executing stuff in our program, but it's going to cause our server software to listen in the background. Essentially, it's going to go into a loop that's going to listen for web requests from browsers and respond to them by calling this function. Now, I know if you are a beginner, this is all sounding complicated, but all I'm trying to do here is kind of give you an idea about what's going on and sort of get you used to some ideas, begin to get you used to them. But we're going to be analyzing all this kind of stuff later on in the course in a lot more depth. So let's now run this program. I'm going to write node and then my script is server.js, and we run it and it says listening. So it's running, and you notice I haven't got my prompt back. To actually stop this program, I have to do Control-C and then it stops. Let's run it again. So the program's running, and if we go to a web browser now, let's try it. So I need to type localhost, localhost, which is essentially the name of my computer here, colon 8000, so 8 and 3 noughts. You can see that. localhost:8000. Let's run it. Localhost:8000. Let's run it. My web browser is sort of hanging as though it's loading a page. Yours might respond different. Browser is sort of hanging as though it's loading a page. Yours might respond differently somehow. I don't know. But we have actually made a request to our program. If we look at the terminal, it's actually output hello. Now what we really want to do is send some data to the browser rather than just having it trying to get data and just hanging like this. So let's stop the program. So let's go back here, do Control-C. How do we send data to the browser? Well, we use our response object. Remember, when we make a request in the browser, we call it an HTTP GET request. It's like a request to get data from this server program. When we do that, this function will get called, and the response object here allows us to respond to that request. So what I can do is I can write response dot write, and let's output hello world semicolon. And after that, let's do response.end round brackets, and this basically is going to tell our browser that that's it, that's all the data that we're planning to send. So now let's try this. So I'm going to start up my program again, node server.js, go to a browser and go to localhost 8000 hello world server. Hopefully it works for you. I think actually Chrome is what I'm using here. It hides the sort of full URL from me. I think it's actually http://localhost:8000, but it only shows the localhost 8000 bit of it in this version of Chrome. So what we've done here is we've written a program which, if we go to a browser and we go to that URL localhost:8000, that's the port 8000, that actually makes a request to the server program we've written, which is listening on that port, and our server invokes this function to send data back to the browser, and it just sends back some text which is usually going to be displayed in your browser. It's possible another browser might ask you if you want to download a file, and you're going to end up with a text file that says hello world server in it, but I think most browsers these days will just display text data that are sent to them like this, and certainly Chrome does. Okay, we'll leave it there for this video. The thing to do with this, if you're new to this, is type it out for yourself and get it working. Hopefully you can get this working and experiment with it a bit. If you encounter any error messages that you don't understand, try to pick out the most important bits of those error messages, paste them into the internet and see what the internet says about them. But you might need to add Node.js onto the end of them or something as well. But you should be able to get that working, and it's really important to type it out for yourself. You can see my code on github.com/caveofprogramming in my Node.js public repository, but it's no use copying and pasting this. You've got to type it out to really begin to get familiar with it and get the thing working. Let's stop that with Control-C again. Okay, so we'll leave it there for this video, and until next time, happy coding.